All right, guys, I'm Old Man Builds, and I'm here with Merkaba Magnetricity, and we're looking at his invention right now. You want to go ahead and explain it? I'll go ahead and put up a video real quick and just show everybody what it looks like.
From the ball without.
There you go. We're good. It's up.
Right. So it's hard to explain where it's really come from. I started looking at sacred geometry back in 2003, 2005, and it just something clicked with me that this shape, the Merkaba, the stellar octangular, can easily be wrapped with wires as a coil form. And just something in my head said this is going to make a generator, and that's where it sort of started. Lots of YouTube diving, and it literally has just come out of what happens. I don't know where it comes from, but it just seems to make sense what I put together, and it works. This is what I find intriguing. But it's basically based on a feedback loop. I use audio amplifiers to spin the ball. And the reason I do that is because before I built the machine, I was talking to an audio technician, and I was asking what the sound was when you put the microphone next to the amplifier, next to the speakers on. And he said that was the sound of eternity. And again, it just clicked with me, which, you're making a feedback loop. And to me, those three coloured coils that you see there, the large ones that wrap round, make an octahedron. They're connected in series, and they generate a magnetic field, but they're acting as a speaker. And on each of the points, not on this version that you can see on the screen, but on the latest version, it has one on every one of these cross points where the intersections are, which again, the whole shape lends itself to this. So then there's fine wired coils on each of those 6 intersections. That's acting like the microphone, and they're literally just put through an audio amplifier. And as you start the ball spinning, I only switch one channel on, and then allow it to get up to a certain speed. It's a bit like driving a car. It feels like you're changing gears. So then when it gets to a higher speed, I turn the second one on, the third one on, etc. There are some videos that on. And the way I like to think about it is it's the sound of the magnet, playing the sound of the magnet spinning, that makes it go faster. It's almost like hallelujah. It goes round and round. It can hear itself spinning. It's an audio feedback loop, but with electromagnetism involved, obviously.
So, just real quick, you put a coil where they meet on the corners. Is that what you were saying? So that it starts up the ball?
What you have to do at the current builds is you just get a magnet and give the big ball in the middle, the ball neodymium, the spherical neodymium, a bit of a whip, and that little spin. And it always has to spin. If you look down, it has to spin clockwise. It won't spin anti-clockwise. Whether that's something to do with the wiring, the way I wired it up, I don't know. So once it starts spinning and the amplifier is turned on, it takes a little bit of tuning with the bass and the treble and the volume, and then it just starts spinning. And it doesn't want to stop. If I can get it going faster with lack of friction or hovering the magnet, there's lots of different.
Sorry, give me 1 second. I'm looking for something here. You move your hand. What is that doing? Like when you
when I flick it, So when I flick it to start it going earlier, there'll be a magnet in my hand, and that's just to interact with the magnet in the middle. So that's not it, is it? But yeah, you can see at this point as well on this early version we're looking at here that I've started to put those coils on the points. You can see a green one here on the left, a yellow one to the back, and one above. There is one below, and there should be one on the right.
So it puts out sound like a speaker, is what you're saying, with your audio amplifier.
Yeah, the thicker wires are the speaker wire. Yeah, so they're attached to the output, and the input is all those 6 small coils, but they've all got individual switches to switch them on one at a time, because you can't just switch them on all together. It just makes a horrible sound and won't start spinning. You have to have just one feedback from one of those small coils and then turn it on. And then once it gets to a certain speed, then you can introduce the next coil. And there is a sequence that you find that it's like tuning an engine. You know, I think it's unique to itself at that point. And the new build, which I'm on with, I've not got that up and running again, but I should expect I'm going to hit a lot of the same issues I had there, trying to find out which coil reacted better and move them about until I get the sequence so that I know which order they need to be turned on.
So you literally are putting a symphony in this thing. So one, then the next. It's like a different chord on your guitar or something. Just one, then the next, and then the next, and it just makes a beautiful musical tone. But it's spinning the magnet while it's doing it.
Yeah, and that, you know, there's a couple of videos that I've spoke to you about in the past that I did some experiments for myself, just 3D simulations to see if what was going on. So the only thing I knew how to use simulation-wise was 3D Studio Max, and I put because I had 3 coils, these three speaker coils on those 3 axes. It is identical to the Montauk Delta T antenna. I'll see if I can get a link for Nathan to put in the comments.
But can you explain that just a little bit of what he's talking about?
The Montauk experiments, it's what Stranger Things is based on, if that's right, where they did mind control experiments. Is it an Air Force base? It's closed now, but supposed to be closed. But there was people that took place in these experiments, and one guy built a Delta T. What did he say it was called again? Delta T antenna. That was it. I couldn't believe it when I found that information out, and I was already building this thing. And they start talking about really exotic stuff, like time travel, and yeah, it's interesting stuff. But,
It's almost like an open air resonance chamber that you have sitting right here in front of you. Because as you put in sound from different direction, it creates different things. So it's almost like if you put a core around the whole thing of it, man, it would change the whole thing coming out.
Yeah. There's the idea that you can introduce frequencies onto the signals. I've attempted something similar, but every time I did it, I went off and read about it. You can't put a DC signal onto your inputs, otherwise it just causes something in my amplifier to shut down. I'm always frightened of blowing them up because they're hard to come by, these good ones. But I would like to, you know, reduce the size of it. But the one that I built previously out of brass works. I don't know if you've got a picture. I sent you or the video I sent you earlier.
I could show it.
Build. Yeah.
So this one right here.
Yeah, so there's the old one that you see in videos of currently, and this is the new build on the left. I bought the 2 printer there. I bought a Creality K1 Max, and it's been 10 or 15 years since I'd owned a printer or bought a printer, and the technology has done fantastic. Oh, that was it. Yeah, sorry, exotic propulsion thing. The operator would sit in a chair. Didn't they put a big one there as well? Like a giant as well.
You had a bigger one on there?
No, I didn't. But exotic propulsion's distracting me with his talk about the Montauk there in the chat. Yeah, so the one on the left is the Mark II, if you like. I'm currently replacing a lot of the steel screws I've used, even though they're stainless. I want to replace them all with brass because the framework's that extruded 2020 aluminium. And the way I built it, I've designed it so that I've got all these parts, and anybody, if they want to build it, could build one of these things and start to experiment with it. But it's far superior to me. I was always very frustrated with the fact that even though I've got these skills in an old 3D printer, I never built anything other than the little blue thing you saw in the middle to put the ball in properly. And this chamber is all designed to take the mercury. That's where I'm going with it. It was interesting to hear Exotic Propulsion talking on the last chat that he had, when he was on about something that I'd just this last couple of months had come across myself, that there used to be mercury buoys on the sea that were self-illuminating, and all these were Tauruses filled with mercury in a vacuum, and the rocking of the waves would light them on the sea so the ships could see. And this is going back to 1800, this diagram that I showed. I think I sent it to you, didn't I, Nathan?
Yeah, let me take a look real quick. There's a lot on here.
Yeah.
Yeah, let me look.
There you go. So that
Oh.
writing
Sorry,
is
not that.
like a page from a book, black and white page from a book. Keep going. Yeah, look, there was only one there. Why is there only one?
Oh, sorry. This one. Is that what you're talking about?
No.
This one?
Yeah, it should be with that one. Is there only one there?
Yeah, I'm not seeing it right now. It pulls up all the pictures
I'll
that
forward it.
are sent to my Facebook. Just send it in and I'll pull it up real quick.
So yeah, this is the image that I saw, and it just said self-illuminated buoy, and that sent me down the rabbit hole. And again, it was one of those things about this machine, not Exotic Propulsion, but the same sort of experiences when you're doing your research. In your head, you always knew that you were right, and then you start finding things like this that tell you that you were all along. And one of the videos I sent you was me holding the ball back in 2013. Since I've been building prototypes for the core, that was the bottom of our chat. And I've always put a Taurus in. Did that one just come?
That one just came up. Yeah.
Yeah, that one there was back in 2013 when I had my really old printer, and I'd put a Taurus in then to take the mercury. That's what I always intended to do. One of my biggest failures so far, not a failure for learning, was that I always found I had a little toy when I used to spin the ball. I know I had you guys going, "Oh, it's crazy, it's open one end." Well, I used to use a little stacking cup from the children's stacking toys, and it was a cylinder, and it always used to spin like mad and spin for about 5 minutes with the inertia afterwards. From the speed that he was attaining. And I don't know why, because I was so pig-headed about it. I've designed everything with a sphere to take the spherical magnet, but that is completely wrong. A cylinder is the best shape if you're not levitating the magnet to put it in for minimum surface area contact friction. So that's
I saw that and I don't remember if it's on here or not, but it looks just like a test tube cylinder. And in the inside, it looks like DNA as it's swirling. Is that in this one? Is that what you're talking about?
Well, the one where I'm spinning.
No. It was just a photograph. It might be in something else I was looking at.
Yeah, no, I don't think that was me.
Sorry, man. I've been looking at a whole bunch of information lately, and it's just been like sitting in my brain. You know what I mean? Festering. I'm trying to figure it all out.
Yeah. Well, it's a rabbit hole, isn't it?
Oh, it is. It definitely is.
So where I'm going to try and take it, I think one of the guys in the last live stream, one of the last live streams he did was mentioning whether or not the mercury will be generated pressure inside the Taurus that I've currently got it in. And yes, it will be, and it will always will, no matter what I put. I'd like to think that would create enough pressure for maybe is it barometric light, exotic propulsion you're talking about? Is that the phenomenon we're talking about when the mercury glows? Oh yeah, barometer light it's called.
Give me 1 second. Just interrupt you. Everybody's saying your volume's low. Is there any way you can turn that up?
My volume.
Yes.
If I dump the headphones, turn Bluetooth off. I don't want to lose you. If I do, I'll hop straight back. I'll take the headphones off. 1 second. I think you're still there. Okay. Turn these off. Just need to turn the microphone. Are you still there?
Oh no. Yeah, now you're super loud. Okay,
All
go
right.
ahead.
So there must be a microphone in my son's earphones.
Oh,
So yeah, it is generating pressure, and where I'm going to go with it currently is I'm going to cast and pot it once I've wound the coils on the on the Mercury core with the Taurus. I don't want to get it out and drop it, but you've seen this in the video. This was in the screenshot. So what I intend to do is, once these are wrapped, is to pot it, and then if I do need to get the Mercury out, I'll have to drill it out. They're only cheap, these Tauruses, to get hold of, but once it's potted in epoxy resin, that should hold it. But that motor, did you play that already in one of your other videos?
I'm going to play it right now. Hey, I had a question right before I do.
Yeah.
The epoxy resin, does the mercury interact with it and eat it?
I don't know, but it's not going to touch the epoxy resin directly. It's already in a plastic tube, and plastic's safe to store mercury in. There are better things. Iron is one of them, but I can't use iron because of the magnetic core. So it won't be touching the epoxy resin. I intend to cast a plastic Taurus inside with all the coils and to house it in case it does make any pressure.
Gotcha. Let's take a look real quick. I'm going to put up your first mercury one, and I'll pull your second one.
Okay. Loud is good. So yeah, this is the spherical magnet spinning in a spherical housing, and sometimes you can hear it struggle, and I don't think I would have got as much it wouldn't slow down as much, because obviously there's a diamagnetic thing going off, because mercury is diamagnetic. So it's like when you hold copper near magnetic braking, they call it, don't they, when they use copper to slow, I don't know, roller coasters and things like that. So the mercury does slow the magnet to some degree, but this one is fantastic because it you can see a double vortex. When I had it held vertically, the Taurus, you could see a vortex developing at each end of where the mercury terminated.
So let's take a look at that real quick.
There, that one. Yeah, and I should have another go and see if I can get in closer with the camera, because I've got a better camera now.
You can see it. If you look at the right one, it's starting to indent into it. And the left one.
Yeah, it's literally creating, well, it's trying to join up, I guess, is it? If they're both creating a vortex from...
It's trying to create a hole in between it.
Yeah. Yeah.
That's neat.
That was just one of those things that you just observe while you're doing these things, because I'm not a scientist. I'm just a practical person, and this stuff interests me, and it has done for a long time now.
I think it interests all of us, man. We're all into this stuff. Let me pull up the other one real quick.
The test bed.
Yeah. So it's this one here.
Yeah, so I'll let you play it and then I'll explain it. So that is a radio controlled drone motor.
Okay, hang on. I'll just remove this. I just want to have you show it a little better. So
yeah, what I've done here, it's a test platform, if you like, because I'm still rebuilding Mark II, let's call it. There's a couple of things I need to know. I'd seen a guy, Matt, from
Elevate Cultivate, I think his channel's called. And he got a tri-field meter and he shook mercury in front of it. And again, it said to me, I was right all along, because what I'd seen that got me on the mercury thing was the Faraday motor. And all of these things that we're looking at here, the basics of it, copper coils and magnets, Peltier devices, LEDs, mercury. What's the other one? I've got a list. I sent you a picture, actually, with the 5 equations, as I call them, on. Can sound cause eddy currents? I don't know, Sean.
That's an interesting question.
Yeah.
I don't know that it does, but it may. Let's look at the so on this one, I'm going to mute it here.
So
You're
what I'm trying to
forcing
do,
the magnet.
yeah. So there's a magnet in the middle there. Normally, my ball obviously is magnetized top and bottom, or left and right, whichever way it falls in the chamber. And whatever those fields are doing to it is how it'll lay. So what I've done here is I've got a diametrically magnetized disc magnet with a hole in the middle, and where the propeller would go on the RC motor, I've just mounted it on there. And then I've worked out my heights and distances and built this 3D container to sit the mercury in there with the torus. And I want to take some readings. The readings I want to take are, I want to do an empty torus that's wrapped with coils and just read the electromagnetic energy coming from those as a baseline, and then duplicate wrap the windings on the mercury torus and take those readings and see if there's a difference in the electricity, and see if it can be taken out of the mercury just by using the coils around it. I don't know if that can be done, because I'd envisage that you should actually stick a cathode and an anode in it to extract the energy. The magnet's causing spinning. The magnet spinning, Sean, is causing the mercury to flow.
Let's put this one up. Okay.
Phone on sound and light. I don't know what that means. So yeah, that's where this platform's at the minute. This is just a test platform, because I wanted to replicate what the ball magnet does in the core of the Merkaba generator machine, and this is just a test platform at the moment.
So we saw the we saw the coils in the first experiment. How do they translate to this experiment? Because you were putting the sound throughout.
Yes. So what you saw in that earlier video, using a torus near the core of my machine, and that's using a ball magnet, and obviously that's causing the mercury to spin. So we know that happens, but where my build's at the moment, I need to know some things before I finalize a design, or I say finalize, it never finalized. Before I build the actual core, I need to know some things about what the mercury is doing, how we're going to get the electricity out, the diameter of the torus and things like that. I'm filling my head up now. There's lots of things to try and look at. Where do you draw what?
What's that? All right. Which one?
Sorry, it's
all right. Go ahead. I'll put it up so everybody can see it.
I wonder if you could get gyroscopic stabilization if the mercury or the plasma could be spun fast enough. Definitely going to be a force that we're going to be reckoning with, isn't it? You mean like the bicycle wheel thing where you spin it and hold it? Is that what it means?
I think so.
Yeah. I should imagine you will get some kind of gyroscopic forces at play. But it's heavy stuff. And as soon as I turn this RC motor off on the test bed, the mercury doesn't keep going, not like the magnet does.
So the mercury just stops?
It'll just stop. Yeah, it's heavy stuff, isn't it?
Yeah. So
very heavy stuff.
Tell me about the windings here. You have spaces for the windings in here. What are they going to do in this particular situation?
Okay, this is where it sounds a little bit crazy. So say what you like in the comments. My original idea to try and get the energy out was to wrap the whole torus with copper windings all the way around. But I've always known, could you, just one second, Just 1 second. I'll be straight
Yeah,
back.
go ahead. Sorry about that, guys. Yeah. Let's go ahead and read a couple of comments. Crystal lattice that could be thought as tangential structures. That's interesting. All right, y'all good?
Yeah. What was I saying?
We were talking
Right.
about the windings, and instead of going full
Yeah,
coil
so-
around.
So I was going to wrap the whole coil with copper windings, but I've known since the beginning that there's 5 things I want to use, and the LEDs, turning LEDs into like a solar panel is one of the ways of pulling. It's a reversible equation. If you give an LED electricity, it gives you light. If you give it light, it gives you electricity. And obviously, the mercury in a vacuum with a barometer light or whatever exotic propulsion called it, it's going to glow, and that wants to be harvested. All the energy from the machine is, in my mind, is what you need to aim to harvest it all, whether it's heat, sound, light, and the spinning of the mercury. And but it's UVC light. So I suddenly realized when I started wrapping this coil with this copper wire that if I cover it in copper wire, I'm not going to see the glow. So I separated it. I put those separations in and made coil forms where I can wrap the wire. That's what those white sections are that split it up, and it ends up looking like Iron Man's heart, which is crazy, but that's what it's practical because it's going to let the light out. So you've got somewhere to put UVC LEDs, because that's where I'm going with it to test. You can take a normal LED and hold it in the sunlight and test that you're getting a voltage, and you'll get a voltage. But you can't do that with UVC light that the mercury will give off. It has to be a UVC LED, which makes sense. It's doped with a certain.
There is an
chemical.
unfortunate downside to UVC claimed LED technology. So it's really awesome to have you on here. I actually have some of your videos, Merkaba Magnetricity. I have some of yours saved on my anti-gravity playlist, have had for years. And it's super awesome to actually see the guy behind the channel because I love the work. And it's brought up a lot of conversations amongst our private research groups as well, because, a lot of us, we played around with Mercury and rotating systems. But as far as demonstrations go, you have some of the best. So it's a pleasure to meet you.
Thank you.
What I've got here is a little vial of mercury. There's some contaminants floating on the surface, which should help with visibility. I've got a Dremel tool here that has a 4-pole in-runner BLDC rotor. So north, south, and that's going to induce a rotating field, very much like the 2-pole or dipole magnet ball. And then what we're looking at here is a homemade magnetometer probe that's hooked up to the scope. So unfortunately, there's a little bit of variation. I'll just zoom in on that to show the problem that it has. But you can see that there's a bit of a spiked waveform here. And that's because the internal voltage controller in here is generating some noise. So that's not part of the signal. But what I will show you is if I turn this rotor on, sorry for the noise.
No problem.
So it's running at a relatively low RPM. We can see that we're generating a sinusoidal pickup by our Hall effect sensor inside this probe that's located right here. And if I increase the RPM, so what I'll do now is take this small cylinder. I'll tilt this down so that we can see it. All right, let's see if we can get any kind of camera view that works for this. That might be more tricky than I thought. See, can we, I'm not sure how well that is focusing. Guess I'll hold this light up next to it, perhaps. And maybe we'll be able to see some rotation. Tell you what, give me a second. I'm going to move my camera back a little bit. There we go. That should work much better. And plug that back in. There we go.
Yeah.
So the signal start to tilt up. So now the surface is rotating. It's not moving very fast. The electrostatic induction and the magnetohydrodynamic induction is not particularly strong in this case, but there is a bow in the center.
Yeah.
Unfortunately, this vessel is really very poor choice, being that it's darkened glass. But there is another thing that I put together a while ago. Unfortunately, during daylight conditions, I can't really show it very well. But this is a 2-inch diameter.
Is this the one you pulled about?
Go ahead.
Is this the one you pulled a vacuum on?
Yeah, this is the one I pulled a vacuum on. And so inside there, you can see the puddle of mercury. And so all I did is swirl it around like this, about this speed, and in a fully darkened room, which won't be possible with the low CCD sensitivity or ISO on my iPhone camera. But just spinning it around at this RPM, you're generating plenty of light. You can't quite see where you're going, but I did another version of this where I put in a bunch of phosphors from a fluorescent tube and just let them sort of float on the surface of the mercury. Well, they would get stuck. They would want to float and then get pushed against the wall. And as the mercury flowed across the phosphorus, it would convert the UVC light, as you mentioned, into visible light, which had quite a plethora of colors as the phosphorus kind of got isolated from each other. So we had reds, blues, and greens that were all clearly identifiable. And such a low RPM. I mean,
yeah, very low.
We count the RPM of this rotation here of the oscillation of my hand, and it's really not moving that fast across the surface. So you can imagine, just if this was a very large diameter tube, say like a 2-foot wide diameter by 1-inch cross section tube, and it's just tilting back and forth, that buoy, it could reach the same kind of velocities that I'm achieving there by hand and easily generate enough light to be seen in the extreme darkness of the open ocean at night.
Yeah. Had you come across that diagram that Nathan showed us earlier?
So there's a lot of really interesting stuff too with mercury. And one of the stories that I heard, and consider this speculation because I've never been able to verify it, but a gentleman that I had a chance to speak with over the phone, he had a very curious experiment. And what he did is he took a small pool of mercury, not much larger than what's inside this glass bulb, and wasn't under vacuum or anything extreme like that. And he had used a pulse metal detector, which is, there's 2 types of metal detectors. So you have your first type, which most people know of. It uses a sinusoidal waveform, and it looks for an active feedback. And the second type generates a quick pulse, and it works more like sonar. An electromagnetic pulse travels down from the coil into the surface, into the ground, and then whatever comes back, that pulse is already over by the time the pulse is received. So it generates a very high electromagnetic field in terms of its amps per meter. And so when he induced that field onto a pool of mercury, he had noticed that a variety of colors were produced under normal operating atmospheric conditions. And he got quite the plethora of colorful aurora-like glows off the surface of that mercury. And so it seems that electromagnetically, if you excite the mercury with a high enough power pulse, there is yet another level to these effects that we haven't even seen yet. And I believe this is partially due to, if we consider like the surface of the mercury and the surface of the glass as having some sort of triboelectric stiction interaction, and then looked at what he had done in his system, he was effectively inducing the same types of surface potentials that would normally happen inside the glass. Only he was doing it wirelessly with this pulse metal detector. So there could be a lot more to the power of mercury I'll switch off my cam for a second, and I'll pull up a PDF and show you guys real quick Thomas Townsend Brown's design of a Mercury power generator.
I did not know he did one.
That's why I love these things, man. You kind of learn everything from everyone. Give you some new ideas to try in the future. Seems like T.T. Brown was into everything.
Brown was certainly a genius of his time. There's no doubt about that. And he did get into quite a few things. The biggest catch with what people misunderstand about Thomas Townsend Brown is they've got this idea, and I don't know why it was so popularized, perhaps between Jean-Louis Naudin and a few others. People got the idea that Brown had stopped at lifters. Now, I imagine everybody that watches your channel, Old Man Builds, has good familiarity with what a lifter is. It's this little triangular form airfoil, very lightweight, uses electrodynamic potentials in order to produce a lifting force on the hull. Now, I've studied this quite in depth, and what I found is that the ionic wind produced can be almost completely eliminated, meaning that you basically have no airflow in order to produce lift. It turns out that what really happens is at the top of the ionization wire, instead of just having ions flow down from the ionization wire towards the collection plate and generating an airflow, which is equivalent to a thrust, what really happens is the ions also fly upwards away from the collection plate. And they create a huge cloud of charge above the collection plate. Well, now you've got a massive amount of free-floating ions, free unbound charges that are now flying around the atmosphere, and the amount of volume that they take up in terms of the atmospheric gas density is, or can be, greater than the amount of weight for the craft hull, meaning that instead of the craft being pushed by thrust upwards in order to create a lifting force, what it actually is doing is being electrostatically attracted like a capacitor plate towards the area of opposite charge density. And that's being done due to volumetric displacement of the entire atmosphere. So the craft may travel upwards at 20 miles an hour, while the atmosphere that's surrounding it, because it has several hundred times the total volume of the craft surface area, it may only be traveling down at maybe a couple inches per minute.
So funny, man. I can't get people to understand that simple fact. Charging things changes everything, and the lifter isn't working the way you think it is.
Not at all. No, I mean, we've gotten lifter technology to the point where it's 4-to-1 ratio, no problem. And if I include power supply, it's still 1.5 times 1.5 to 1 ratio in terms of power to lift. And the reason why I haven't released this is because I'm friends with Ethan Krause. He's the first guy with Electron Air LLC to ever release a full VTOL type of device that can use nothing but electrostatic charges and ionic flow in order to produce a self-lifting craft. So it's all self-powered. It's got a battery on board, and Ethan Krause has a patent on it. So long before MIT and their famous Ion plane had ever taken flight, Ethan Krause already had a VTOL craft that was fully operational and radio controlled. So MIT was second to the game, but of course they got all the news press because big organizations, that's how academia works. They don't care about the little guy. But nevertheless, Ethan did it, and he's been doing it for over 20 years.
And people wonder why I use charge instead of magnetism in my gravity flyer. It's a whole different way of looking at it.
It absolutely is. So let me go ahead and turn this on. So this is going to be a little bit crude. I do apologize. I'm on my cell phone and my document is on my computer. But this is Thomas Townsend Brown's Mercury power generator. And what he's got basically going on here, I'll just show you here. Here his signature is at the bottom as the inventor. And it was signed off by 2 witnesses that seen the machine operate. The name's here. And this is February 24th, 1933. And so what we have here is almost identical to a Vimana engine in the classic Vimanika Shastra documents. And we have a round boiling flask. In Brown's case, it was Pyrex. He has a constricting nozzle here, part B. And part B here, the mercury vapor that flows up from the surface of this heated flask, which was heated with a flame in his case, but now could be heated easily with electric heating element. The mercury flows up through this nozzle. It accelerates because the nozzle is thinner than the total volume of the surface area. And it goes between these two electrically charged plates. So we can see we have these terminals here connected to these metallic plates on one side and the other. If we look at it from top down, we're looking at the metallic plates that we just seen there on the top and bottom. But on the sides here, there are two massive solenoid coils. And we can see, I'm not going to rotate my camera because it'll just flip anyways, but these two solenoid coils are orthogonal to the electric field plates. So through the principles of MHD, as the mercury gas accelerates up this nozzle here and starts to flow towards the top and back into the condenser region, the differential in ionization between these individual mercury ions that are being boiled off of the surface of this liquid pool here, well, they're diverted away by the magnetic field. Now, of course, today we would use permanent magnets for this application. We wouldn't use field coils as he's showing here because field coils are going to consume power. But this could be completely done with permanent magnets, and then the only power input required would be whatever the differential is between heating the mercury and then condensing it back in this condenser. So you're going to, the mercury ions follow the right-hand rule, and this was able to generate a potential between these two plates, and he was able to extract power off of this. And it's a very interesting means and method of creating a device that can extract power from flowing mercury vapor. Later on, let me see if it's in this document. Yeah, here. So he actually does build where there's a full condenser on the top. He's got this nice large water-cooled condenser, and he's optimized the design in the final drawing, and this is what it looks like. The shape of the dewar is changed. There's less mercury inside of the system. There's a much thinner restriction nozzle, and so the velocity is higher. And then the return tube, after it goes into the condenser here, it is extracted, puts it back into a liquid state, and it drips down through this return flow back into the mercury boiler down here at the bottom. So it's not a particularly complicated device. And he shows some of the switching for how you can extract. He draws this up, and in the text, which I'm not going to get into too much, he describes this as a preclusion to a patent application, but it never got to the point of actually being patented, never even got to the application stage to do with mercury that's not being done. And of course, we know that pretty much across the board, our governments have done their very, very best to take mercury out of the hands of the civilian.
Yeah.
There are good reasons for that. I'm not gonna say it's a conspiracy or anything like that, but there are good reasons. You know, mercury is technically, toxic to the environment, toxic to human life, especially the vapors. In its aqueous form, it won't actually absorb into human skin unless, of course, you have sweat on your skin, which is pretty much 24/7 for humans. We always have some kind of salt on our skin. So mercury will form a salt, and when it does, it can be absorbed into the skin. Otherwise, if your hands are completely dry and completely free of oils and completely free of salts, you could roll around a pool of mercury in your hand and it wouldn't pose any particular danger. This is an old classroom physics demonstration that used to be done, but now is, of course, completely forbidden because, well, people don't understand the dangers or the lack thereof involving mercury experiments. Although I would certainly say for anybody trying mercury experiments at home, definitely don't unless you have a proper enclosure, a vent hood, and at least some catch tray in case you have a breakdown of your enclosure. So you want to be able to catch that spilling mercury, obviously. So don't try these experiments unless you really, really know what you're doing.
Yeah.
It reminded me, the diagrams you just showed us, you can't help but think of Vimanas when they're heating the mercury from the bottom. That was in the text, wasn't it?
Absolutely. The Vimanika Shastra states that the mercury boiler must be built extremely rigid and strong. So they would make their mercury boilers out of iron, which is actually an ideal element because mercury will amalgam somewhat with iron, but because of the carbon content, the carbon will actually form sort of an insulating layer where mercury will not amalgam with carbon whatsoever. And so the carbon would create a barrier where as the mercury was flowing over the surface or being separated, the iron vessel would stand up pretty well to the heat and to the pressure. Of course, it wasn't it wasn't a permanent forever solution. It's not like it was made of molybdenum, one of the two metals that can withstand and not amalgam with mercury under normal conditions. But iron will still technically work in a pinch. And of course, today we would use borosilicate or something else like that, or we would line the inside of the vessel with ceramic. Basically anything that doesn't amalgam with mercury.
Did you see, I put a little video just showing a toy that you can buy. I call it a toy, it's a scientific demonstration toy, a Leidenfroster now.
Did you put it up on the Facebook?
Yeah, I just sent you a link to it. I don't know if you can do that.
Yeah, give me just 1 second. I'll get out of this and I will pop over there. Okay, I have an older gentleman on here who's doing something. I'll share the screen.
Oh, that's an interesting one. While you're pulling it up, I'm just looking at a document here I have from 2017 called Deformed Space-Time Transformations in Mercury. And quite the list of authors on this paper. So I should really send this to especially you, Merkaba Magnetricity, because I think that you would really get a kick out of these. I've got about 12 documents here in this folder, and all of them have to do with mercury involving power extraction or other anomalous types of electromotive effects.
Yeah, sounds good. But that video that it was just putting up then in the Leidenfrost demonstration toy, when you heat the metal, and I'm assuming you could make one of these out of steel if you had the right tooling, and put mercury there instead of the water, and it would still do the spin with the heat.
Well, you don't really get that with mercury. I've tested that, ironically enough, just to see if there would be other compounds that might produce it. But the Leidenfrost effect and the self-rotating assembly happens because you have a layer of steam. And the steam doesn't expand evenly because of the surface being notched and asymmetrical. So when the steam expands, it's forced more out one side than the other, and that applies a rotational force or forward momentum from the point of the steam particles in general to the rest of the liquid water that's sitting on the surface. Well, mercury, unless you're running it at a high enough temperature where you're actually evaporating the mercury liquid into a vapor, which is something that you certainly wouldn't want to do, at least not intentionally, unless you're going to vent it proper. You could get the same kind of effect, but you have to reach the boiling point of the liquid. And I wouldn't recommend that we reach the boiling point of mercury in atmospheric conditions.
No, I would. I'm trying to relate it to the Vimana text in as much as they talk about that it creates a whirlwind, and the only thing that I've ever seen that would start it spinning would be something like this. If it was a steel chamber, steel takes a lot of temperature, doesn't it? Is it 2,000 degrees, something like that, to melt it? So it could take a lot of temperature, way above the boiling point of mercury.
Yeah, but so can ceramic too.
So maybe
ceramic
you could in a
glass are really ideal solutions. As I mentioned earlier, borosilicate is not going to have too much of a problem as long as it's evenly heated enough and the vessel enclosure is thin enough where you're not dealing with thermal shear factors. But yeah, we have better materials today than what were available in Brown's time.
Oh, definitely.
Yes.
CCTO, for example. I mean, Brown was really, really excited when he had discovered a dielectric that had a K factor of 20,000, which in that time was just absolutely insane. 20,000 K, totally nuts. Today, CCTO, which is one of our best available dielectrics, has a K factor when properly compressed of over 200,000. So you can imagine what he might have done with that. But you know what people don't talk about is Brown's gravitational isotopes. The difference that he discovered between various isotopes of common elements. Now, if we look at the nuclear spin chart, and I don't have one conveniently to pull up, unfortunately, but the naturally abundant nuclear spin isotopes in all common elements had been measured for what they are on Earth, and you can actually isolate out something with an extra neutron versus something without. And it turns out that that extra neutron or the lack of a neutron changes the way that it responds gravitationally versus inertial. So according to Einstein's equivalence principle, there is no difference between inertial and gravitational mass. They should always be the same. And that's considered in mainstream physics to be a gold standard, never violated, never disproven. At least that's what we're told. Well, there are quite a number of experiments, especially amongst the fringe community, that are done properly and with third-party validations that demonstrate a clear violation between the equivalence of inertial and gravitational mass. Why they're not being talked about in the mainstream, I've got no idea. I suppose it might threaten the tenure of some long-standing professors, but regardless of the reasons, we know that there is a difference. And we can utilize it. Go ahead.
Suppressed physics, isn't it?
It absolutely is.
100% suppressed.
You've got relativists that are absolutely hardcore on GR and ignore SR, ignore QED, ignore a variety of other theories because they're just hardcore on this idea. They want a physical universe. They want something that's made of particles and matter and a vacuum that's made of nothing because it makes the math easy. And if what you do is primarily mathematical physics, where you don't perform any experiments and you never have to actually worry about whether your idea will fit on a lab bench or be possible to produce, then all that is very nice and good. But if you want to build something physical, if you want to make an actual device that works and that performs, you have to get rid of some of the mathematics because they just don't work in the lab. And as in the famous words of Richard Feynman, it doesn't matter how beautiful your equations are. If it disagrees with experiment, it's wrong. And that's really where we've come to in terms of this research is we know that the physics we have today, it's incapable of explaining the phenomena that we're observing in our garage experiments and our bedroom experiments. And so we know that we need to modify the physics or modify at least some variables within that physics set. And that what we have currently offered to us is incomplete. So though GR is not wrong, just as Newtonian gravitation is not wrong, well, Newtonian gravitation was replaced with a more accurate model that was called relativity. Relativity stepped through special relativity into general relativity after just being relativity. And now what we have is a new model, but it's still incomplete. It's just a partial explanation. So it's not that it's wrong, it's just incomplete. And if physicists can today get over the idea that they're working with something that has plenty of holes in it and not stick so hard to the idea that it must be true, otherwise the math doesn't work out right, then we can get rid of the gauging problem. The regauging factor of the vacuum refractive index is not instantaneous. Today's mathematics consider that if you create an electric potential in free space, that the entirety of all the universe instantaneously regauges to compensate for that electric potential so that there is no leftover electromotive force or no free momentum. And it doesn't account for longitudinal modes or Hertz potentials at all in our current mathematics. So we need to reconsider what we're looking at when we look at systems that are operating in a nonlinear regime or anything that is parametric in nature, meaning that if you change one factor, another factor changes by a lot more.
Hey, I got a question. What were we doing in this experiment here?
That was me trying to think about whether or not you could magnetize a steel ball enough for it to become the magnet in this machine equation, if you like. So rather than have a neodymium in the center, maybe a steel ball, because it shouldn't be affected as exotic propulsion just said. There are carbons in certain steels and they can be affected, but what I was trying to do was stabilize it, and what you find is it'll pull to the middle of these ring magnets because it's become magnetized, but it won't pull down because I guess of the density of the mercury. And it was just an idea I had, and I just made a video of it trying to stabilize it, see if it will sit in the middle, because ultimately I think I said to you in a conversation, Nathan, I'd love to get my hands on some liquid nitrogen and some superconducting pucks and see if I can't get my magnet just a touch hovering would be enough. Just, it doesn't have to be, huge gaps. It just needs to be enough in the air to stop the friction. You saw how fast it goes in some of the experiments you played on your live stream last time. I believe it can go a lot faster.
There's actually an easy solution to that. You don't have to have liquid nitrogen. You could use dry ice. And because dry ice goes straight from a solid to a gas in a form called sublimation, you'll end up with a vapor barrier at the surface of the steel ball that floats on a layer of CO2 as it's worked in its groove into the dry ice. And so you could effectively achieve the same kind of virtually zero friction environment. Of course, there is still friction because you're working with atmospheric pressure, CO2 gas at 15 psi, but still, it's one way that you can get the RPMs up to a...
You could just use a magnetic bearing, can't you?
You could use also a graphite air bearing, which would allow extraordinarily high RPMs.
I built one. I haven't got it to hand. Yeah. It's the one I got a guy to use a rotary saw and put some grooves in a ball bearing that was the same size as the magnet, and I literally ground it down, and I've printed out a housing for it, and I've got air pipe into it. I've just never tried it with the magnet in the middle of the machine, but yeah, I think it would really help.
So you're doing floating on air? Is that what you're saying? On the inside,
that would be the idea. Yes, yeah. Air bearings are fantastic things. Again, that was just a couple of years ago. I looked at that. I think I've got a spare piece of graphite knocking around as well somewhere. I'll have to dig them out and I'll send you some pictures.
Huh. That's amazing.
But yeah, the machine, what I want it to do, like I said earlier, is harvest all the energy that you can create, whether it's a byproduct or you're deliberately doing it. So going back to the mercury, there's the light. I'd love to be able to harvest that, and the electromagnetic energy that's been created by the magnetic ball spinning anyway. You've got the heat generated in the mercury due to the diamagnetic, I don't know, what would you call it? Exotic propulsion.
And the eddy current induction. Yeah.
That happens, doesn't it? And the mercury gets warm after a while of playing. So you've got heat. You got heat coming up.
What's surprising about your video is you've got these coils pretty damn far away, and being that they're so wide and the magnet sphere is so small, normally when somebody designs a motoring system that can reach relatively high RPMs with a good coupling coefficient, the coils are extremely close to the rotor.
Yeah.
In your case, they're many times farther away than would be idealized, and the fact that you're even getting good coupling with your delta T type coil system is pretty impressive.
It like I say, I don't know what, other than the fact that I was looking at old time radios, and I had a book on coil forms, and when I started looking at this shape, this lends itself, the coils don't fall off. And then you've got your X, Y, and Z axes, which is fantastic, you know, for balance. Have you got that video, Nathan, where I I released the particles? I didn't finish telling you the story. I released particles in a 3D environment, and I set up vortex manipulators inside the 3D environment. And when I release the particles, they form the shape of the Merkaba in the middle, and I don't understand that. And all I've done is use the vortex manipulators, or whatever you call them, space warps, on the X, Y, and Z axes, and the particles. I don't know what we're seeing.
Sorry, give me 1 second. I'm pulling it up. Right here. This one?
Yeah. So when the particles are released, I think there's the black and white version of a video. Is there? Did I send it? Tell me I sent it. Yeah, it's just below the Roman swastika. There. Keep going. There. No, next one. To your left. There. So when I release the particles, and the Merkaba is just there for reference. That's all it's doing. There is actually an image of the setup that I sent him. But can you see how the particles are forming the shape of the Merkaba? And
Yeah,
all that is
that's essentially field compression.
yeah, but that's just using an X, Y, and a Z, but they're counter rotating. So there's 6 fields there. So there's 2 on every axis, but
Absolutely.
but they're opposing.
That's your system?
Yeah.
I gotta say, it's amazing work. I just got linked to you and started looking at your work. I think that's the way your brain works and how that came together. That's really awesome.
That'll be the Asperger's. So yeah, there's another one that I sent Nathan. Let me see if I can see it. Have I sent it as a video? I hope I did.
Hold on.
Yeah, it's about 4 away from that one, Nathan, where I found whenever I see that shape there, that Roman swastika with the particles, what I did in Fractal Draw Pro.
Okay.
Go left. Keep going left.
This one?
No, left. No, yeah, keep going. Keep going. We're getting there. There's a video of it there. So what that is it's an old program, Fractal Draw Pro. And I saw that, and you see the swastika and this star quite a lot. And it seems to suggest pictorially spin. But when I drew 3 triangles that you can see there, the black lines where the 3s are, it forms a swastika. Now, how did the Romans know 2,000 years ago that there's some correlation? Because I'm assuming they did. Otherwise, why would they have done this shape? But it took 2,000 years for me to have a piece of software to draw out these triangles to create this fractal, whatever's going on with Fractal Draw Pro. And it generates a swastika in the middle, a spin, a symbol for spin.
Well, they could have simply looked at the flow of water over the surface and in a closed system easily derive this. Actually, Action Labs, I'm sure you've seen Action Labs videos, and he's got a very simple one where he takes a glass slide, a microscope glass slide, and coats it with candle carbon. So he places it over the top of a burning candle, lets the carbon deposits or they collect on the surface, and then he scribes into the surface a swastika type of shape, more curved to the edges instead of being sharp right angles like this. But anyways, the water droplet, it hits it in exactly the center of this structure. It expands out towards the edges, and then as it contracts, the asymmetry of the curvature causes the entire droplet to start rotating. And so this is one way that they could have easily observed this, is if they create any kind of structure, any kind of obstruction, that if you simply push water in and out, the net result will be a rotation in the direction of the spin orientation based on how fast the water flows out from the center point and expands or flattens out versus how fast it comes back in.
Yeah. But we'll never know. We weren't there.
Oh, we'll know. We'll absolutely know. I would never say we'll never know, because we're doing these kinds of experiments now and we're actually getting results. So we will know for sure.
I have a bit of a different take on it, but Yeah, I think that they knew a lot more than we're aware of, and I think parts of our history have been written for us to the point where we've lost a lot of knowledge when it comes to this type of technology. I think it's going to take a lot of, like Jeremiah says, a lot of hard experimentation and who knows, maybe a few people getting zapped here and there, carefully, of course. But I think that it's going to take garage pokers and backyard dwellers in order to do a ton of experiments in order to find what we need, and it's also going to take scientific experimentation for confirming all this and writing the theory on it. But again, it's time. It all comes down to time, right?
That's right. If you're going to get shocked responsibly.
Yeah.
Yeah, as Nathan says, fry it and find out.
That's right.
Yeah, I've got a lot
Right,
of-
and find out. We got to find the limit of it.
What a great quote.
I do it all the time. It's so sad. I always have a broken part somewhere.
I imagine that at this point, like most of us, you have a giant pile of dead MOSFETs and transistors.
Oh, yes.
Yeah.
And you look at the cost of that, and you don't really want to think about it because you know those things are expensive and they're good components. And oh, mercy!
Yeah, don't do the math on that. Then it's no longer a hobby. It's scary.
I got like tubs of stuff that I put away in case I need an extra part out of something I broke.
Boxes, I understand. I have boxes. Yeah.
I used to go around in my Land Rover to industrial estates when it was about 2007, and it was a crossover between CRTs and flat monitors. So loads of people had these things gathering dust. So I used to go and pick them up for free, and I still got upset every time I burnt one of the transformers out, though.
Right, that was the golden era, to be honest.
Yeah.
In that time,
wasn't it?
Oh, on CRT boards, you had large inductors capable of handling several amps of current. You had huge flybacks that could easily deliver over 50 kV. You had power transistors capable of some of the fastest transition times that we currently have on the market. Horizontal deflection transistors, as Gerald will tell you, those are the gold standard when it comes down to speed.
Speaking of which, I got 4 TVs still. I have 2 32 inches and 2 28s, and I have to peel the horizontal deflection transistors out of them because I just blew my last one, and that one was 1600 volts.
Wow.
Oh man, so you really ran out, eh?
Oh yeah. I'm at that stage now where I'm at my last 4 TVs, and I'm gonna have to go digging. And I don't think there's too many left.
Even the 13009s, they're not capable of handling this voltage at all. And those are the common components on the market. You got to go to the now currently outdated and probably will never be produced in mass again, Toshiba transistors or National Semiconductors transistors, because their transition time is way faster than MOSFET. They are technically rated for operation at up to 12 megahertz.
I have a couple of those.
The reason for why you would need a 12 megahertz capable transistor, which is well within the radio transmission range for the ham bands, inside of a television, well, it's ironic because they didn't design it necessarily to be fast in that particular manner. They did design it to be extremely sensitive so that it would have a rapid transition, because in back EMF operation of a flyback transformer, what really produces the voltage is how fast you can shut off the field. So if you shut it off super fast, sort of like when Alexi presses that button and cuts the ultrasound, the rest of the electromotive force is released.
Absolutely.
Yep. Everything that it's doing on the inside now loops back around and hits it again. That's why it's amplifying everything.
Exactly. If you produce a change in the refractive index of space-time, the regauging factor tells us that it has to come back and reestablish equilibrium. So if you produce a change, it's going to come rushing back in as soon as the change is no longer occurring. So even if you have, say, you've increased your field from 0 Gauss to say 10,000 Gauss, but you've done that in a matter of a couple of nanoseconds, and then you hold it at 10,000 Gauss, what will happen is the refractive index will regauge, and you'll have this influx or back electromotive force wave that comes in from the vacuum conditions as they try to repolarize and match the currently electrically polarized conditions that you're producing with your device.
So basically, it explodes out and then sucks back in.
Exactly. If you push pressure out, it's going to come back in, and pressure in atmosphere doesn't work anything like pressure in aether. We like to use the pressure analogies and the hydraulic analogies to describe the behavior of aether or the refractive index or the vacuum, whichever word you'd like to use. They all mean the same darn thing. If you push out, though, in the aether, unlike a fluid, it's not a finite quantity. It'll repolarize in order to completely nullify the extra magnetic fields that are produced, leaving you with a purely electric potential, which is why two electrons can be separated by a great distance and be stationary or not moving relative to each other and still have their electric charge, even as observed by one to the other.
So when I push that button, I'm multiplying that energy a lot, aren't I? Like it's a massive explosion, bigger than the amount of energy going in.
Yeah, you're creating an imbalance, and then because of the way that nature works, it's searching for that balance, and that inrush current is kind of what's smacking it, right?
Right, so you've got your ultrasonics running, you have a semi-stable state. The ultrasonics are keeping the ions trapped, but as soon as you let the ultrasonics go, the ions are no longer trapped, they can freely fly away, and when they do, they produce a magnetic field because they're moving relative to the environment and relative to the rest of the platform. And so in the production of that magnetic field, it's a virtual magnetic field because these are unbound charges. They're not trapped in a conductor, so that they can move right, left, forward, backwards, up, down, and they're not going to be constrained by exerting a force on the physical conductor that carries them because they are free charges. So unbound charges have a very different ability than bound charges. And
but that was the point of putting in the heat, though. So you're going to amplify the magnetism at 1 second, or
right,
less than a second.
For that brief moment, when you disconnect, you'll amplify your magnetic flux, and when it disconnects, you'll end up with nothing but your electric scalar potentials that are left over.
And that's why the back pressure in the Tesla coil was so important, because of the heat. When it shoots it back into a cold system, it immediately changes the field from a charge to a magnetic field in an instant.
Right. Think about the Tesla magnifying transmitter or Wardenclyffe tower. It uses a series of 3 coils. Now, the first 2 coils are the big ones that we need to pay attention to because they're the pumping coils. The outside coil, that's the primary. That puts energy into the secondary, which is on the inside, and is only about a 10-to-1 ratio. Now, it's the third coil that does the real work of conversion. The third coil takes the current and it converts it into pure potential because it's not magnetically coupled to the primary or the initial secondary. It's only being fed by a potential waveform. And so you can actually use shorting copper rings. I've got a few videos. I suppose I could show them and pull them up. But I did a really interesting experiment. I contacted Tesla in a strange way, which in my own mind, at least, it seems like I may have communicated with the man. I have no idea if it was that or just pure speculation on my part. But in any case, I ended up with a bunch of diagrams flowing through my head. And by the next day, I had built a very unusual magnifying transmitter, first kind that I had ever constructed like that. And instead of producing, and that will be it right there, instead of producing your normal bright white to bluish lightning bolts that you'd see flying out of the top load of a Tesla coil, this one was producing red sparks and a violet effluvia that was surrounding the red sparks. Now, to reach the red state, we have to actually get into singlet oxygen in the atmosphere. So that means the electric potential at the terminal would have to have been in excess of 1 million volts, which technically it was. We had the transmission range to demonstrate that we had exceeded 1 megavolt, and the input power was still less than 2 kilowatts. The power supply was DC 20 kV, roughly thereabouts, and using a neon sign transformer and a set of rectifier diodes in a full wave rectifier configuration from microwave ohm transformers, we were able to produce a very type of unusual output that had a very large transmission range. The other interesting thing that was about this system, though, the thing that I've never heard anybody else talk about, is what we've termed plasma rectification. And so the effluvia, or the corona that surrounds the top terminal there, actually has a tendency to rectify the output and produce a net charge, which is capable of grabbing onto atmospheric ions and actually pulling them into the terminal. So you can look at the diagram we're seeing on screen right now and consider that to be equivalent to a radio tube triode. When the output potential is high and in the negative regime, we don't get, we do get mass ionic motion that pulls the ions in, and when it goes positive, the ions are held in stasis and they don't move in. So as the negative ions flow in during the positive side of the cycle of oscillation in this transmitter, extra power is added back into the circuit, which can be picked up by the primary coil, and that's your 4 or 5 turn coil at the very base. And during the other side of the regime, we have almost a complete stop in motion of all free-flowing charges. And so it turns on and off very much like a vacuum tube, just using the atmosphere as the rest of its enclosure. And we don't require high vacuum in order to produce this effect. I've tested it on the lab bench and injected ions from above using a small magnifying transmitter, and observed that I was able to feed power back into the primary DCPSU. And I was able to reduce the total current draw of that system by almost 10%, which I know is not a lot, but it's still significant enough to show that we could drain power from an external source, like, say, the ionosphere, if we could only establish a good solid connection with it. And this device had the potential required, according to Richard Feynman's diagrams and calculations that he had his students do in one class lecture, calculating out approximately, what was it, 700, it was either 700 megawatts and 400 megavolts, or it was 700 megavolts and 400 megawatts. I can't remember which order it was in. But anyways, there's a huge amount of power in the atmosphere. And the funny thing that happens is when we draw that power down from the atmosphere, it self-replenishes at a rate that's faster than what we can draw it, because we're surrounded by charged particles from the sun. And as soon as we create a gap by using them up and giving them a free flow path down to ground to neutralize the Earth potential, they just come rushing back in to repolarize and equalize that potential. So we could have terawatts of power floating around above our heads all the time.
Wow.
And we're doing nothing with it.
Goes to my theory with the pyramids, and that's exactly what they were for. Tesla figured it out years ago. But Tesla also figured out that there was a smaller version that could be given to each individual home, and they can run their own home off the same principle that wouldn't affect their neighbor. Not only would it not affect their neighbor, but it would increase their neighbor's output if they both had the same system. Kind of like two magnets getting close together and their fields interacting and magnifying the field altogether.
That's so cool. So hold on, this thing just, instead of like a lightning bolt coming down, you're actually getting the area that's closer. So you would get no lightning, you just get the effects, right?
Well, according to the original research reports, there were news articles written at the time of Tesla's investigations while he was actually operating Wardenclyffe Tower. So Tesla made a promise to Mr. Westinghouse, his original big investor. And he said to Westinghouse, if you provide me the necessary power that I need to run my magnifying transmitter at Wardenclyffe, I will put more power back into the grid system than it initially takes to start the system up. That was his promise. And with that promise, Westinghouse feeling very indebted to Mr. Tesla, who ripped up his what do they call it? He had a patent with Westinghouse. He was going to get a certain percentage of commission. That's what it was, commission. That's what I'm looking for. And so he ripped up his necessary commission because Westinghouse is about to go bankrupt. And by saving Westinghouse's company, removing his commission for the AC rotating electric field system, aka today's modern motors, Westinghouse felt so indebted to him that he provided Tesla with that necessary power to run Wardenclyffe Tower. And then actually what most people don't know is into Tesla's later years in life, they wonder how, without any kind of major career or not currently being employed with any large project, he was able to stay in the Hotel New Yorker and sustain the rest of his life up to the alleged reported age of 84 years. And so Westinghouse paid for all that. Not only did he pay for Tesla's research into his later years, he also paid for Tesla's investigation into his underground laboratories that actually ran between hotels and were built in underground tunnels. So a huge amount of money was dumped into it.
Yeah, it was in his notes. He actually used to travel between the Hotel New Yorker and his underground laboratory. And rumors are that he built a free energy generator as a backup generator for the Hotel New Yorker. But it's never been confirmed and it's never been found. But either way, Tesla was he was amazing in so many ways. There were a lot of things that most people didn't know. Like the Wardenclyffe Tower that he built was in, where was it, Ohio? Or am I getting that wrong? I'm not sure. But there was another one built in Canada, just in Toronto. Most people don't know about that. So he was doing experiments that people had no idea of when it comes to cross-border and how his electricity flowed. So I don't know, just amazing. Just to add to what you were saying, Jeremiah.
No, I completely agree. Underneath those tunnels that run between the hotels, there are a lot of mysteries in the walls, to say the least, and nobody knows exactly where they are. And because of restrictions, nobody's been able to take simple ground detecting radar or anything else down there and find exactly where there might be cavities or, other hidden areas that Tesla had covered in his time. So we don't really know, but perhaps someday somebody with just the right qualifications will go down there, get the right certifications, or completely ignore the laws and find these hidden gems that lie underneath the streets of New York.
If there's anyone out there that has the credentials, tell them to give me a call. I've had a dream. I know exactly where it is. If, of course, my dream is true. We'll see. Didn't mean to go dead air there.
Oh, sorry about that. No, I'm still.
No, I was just making a comment about a dream I had about a generator that was blocked behind a wall by Tesla's order, and it's something that nobody's ever seen before, and it runs itself, and I don't even know how much else, but it was one of Tesla's pieds de resistance, if you pardon my expression. And I don't think it got to the public or to the knowledge of anyone that was out there. So who knows? Like you said, maybe somebody with credentials or somebody who could slip down there and have a good look might find something like that.
I think, being honest, we have to admit that it's more likely to be somebody to slip down there. The idea of going through a credentialed system and actually getting certifications to go down there and properly investigate is going to be a huge public endeavor. But if somebody just happens to get down there and has enough equipment to peel away the wall and find...
Just like those guys tunneling into the wall over there in, what is it, Israel, onto the Great Wall thing they have there. They were tunneling in there trying to find the Ark of the Covenant or something, and they got caught. Yeah. Do one of those jobs, huh?
You guys remember that story from some years ago? Apparently, U.S. military was deployed somewhere in the Middle East, found a cave, went into the cave quite deep, met themselves up against a barrier that was causing harm to the soldiers, and
Of
apparently
pure
they
white,
managed. What's that?
of pure white diffused light. I've heard that story.
I can't remember exactly how they described it, but you'll probably remember more about it than I will. I didn't in the story that I read. It was very early on, so I didn't actually track the whole thing down and see how much value there was to it. But I do remember it being related quite to this. And so they went into this cave. There was some kind of energy barrier, almost like your modern invisible wall from Star Trek or Teleforce type of wall. And so they managed to somehow disable this, went inside and found a almost 5.5 foot tall Vimana. Looked like a wedding cake, stacked in layers. I think it had, in this case, I think it was 5 layers, but don't quote me on that. Anyways, they found this layered structure, and it was some kind of a small craft that, in the end, the story says these soldiers tried to get this craft active or move it or get it out of the cave, and they all ended up disappearing. So take it with a bag of salt, but it
got in
does,
the craft and left.
it does kind of remind me of some of these strange anomalous ideas
I heard
we're talking about.
something about that story. Apparently, yeah, the military have that area locked down and they concreted it over because they can't get it out. But like you, I don't know how much truth there is to that. It's just, I'm not even sure where I read that, honestly.
Okay, I have a couple of questions here. I'm showing some pictures and stuff in the background. I just kind of want to know what they are, if you don't mind. Like this one here. What's going on here?
Right. That.
Can you zoom into the more intricate structure there on the bottom left?
Is that like ball lightning or something?
I don't know if I know how, but let's see.
These were found.
Can you pinch to zoom on your mouse pad?
Yeah, it's not going back and forth.
No, he's in Facebook.
Oh,
Messenger.
yeah. If he's on a desktop, he's not going to be able to do that. On a laptop, it's very easy to pinch to zoom.
Control 0. No. Control plus. Nope, that doesn't work either.
Nothing.
Anyway, so let's talk about what we're looking at. We know that for a while Russia was allegedly generating a series of what looked like anti-gravitational or levitating spherical craft. The sphere was a pretty common shape that's reported, so it looks like this may be something related to that.
Yeah, these were found in Troy. They were dug up in Troy in an archaeological dig in 1880, something like that. Can't remember exactly. But what I see, again, it's like a 3D representation of that Roman swastika mosaic, the one that we showed you earlier. But when you look at it, it's this as well. So if you imagine that the swastika is representative of a spinning core, and then those 3 axes, that's what I see. That's my interpretation of it. And these things are found a lot. So that little UFO painting, I think any UFO buffs will know, the guy in the star that you just had up, the little guy crouching in a star with a blue background, Nathan.
Gotcha. I'm on it. I was just trying to get that picture so I can zoom it in. Go ahead.
And you keep finding this 8-pointed star, which is what a Merkaba is, with a point in the middle or a circle. In fact, when they replaced underneath the Dome of the Rock in Jerusalem, there's a little cave, isn't there? And they replaced the carpets not long back, and you can find these pictures on the internet. 2017, I think they replaced the carpets. And when they pulled the carpets back, there was an 8-pointed star on the floor with this circle in the middle.
Yeah, that's why the carpets are there.
Yeah, that's what I thought. Exactly what I thought.
Wow. Now that's pretty cool.
Yeah, and then when you're talking about flight and these anomalies in this, I think this is in a monastery somewhere. It's an altarpiece, I think, that spaceship. It's above the crucifixion, isn't it? I think a reverse search on Google would find it. But whenever I see these shapes, it draws me in. You know, these 8-pointer stars or 4-pointer stars, because I sent one to you, Nathan, where it's a picture of, let me find it, I'll forward it back to you. It's the when you rotate in 3 dimensions, the Merkaba 33 degrees across the points, you're looking at a 6-pointed star, the Star of David, which I think's just probably just coincidence, but it's interesting.
Kind of like part of the hidden secret of the Freemasons, 33 degrees. Maybe it has something to do with the secret of spin.
The windings on my machine are actually 33 windings of twin cat wire. That's what I use.
That's very interesting. That's amazing work. Thank you.
So there's actually 66, but it's 33 twin.
Can you explain that a little bit more with the significance of it?
Just to verify too, 66 windings. I'm assuming that means you're running them bifilar.
No, well, no, they're in series. They're joined. So
Okay, so they're in series, but are they running one way? Your first 33 is running one way, and your second 33 is running the other.
Yeah. So as I wound it, I go clockwise, and then clockwise, and then start the third one clockwise. So they're all following, but they're in series.
Oh, okay.
There are only 3 different colors.
To answer the question, then yes, that's called the bifilar configuration.
It is bifilar, is it?
Yeah, when you take 2 wires and you wind them simultaneously, like a twisted pair from a network cable.
Yeah, like bifilar pancake coils.
Right, and then you connect the end of one wire to the beginning of the other in the same rotational direction. They call that a bifilar configuration.
Right.
Okay, so just so you know.
Which is one of the secrets to the Gerard Morin washing machine motor / the actual PMH that was used in the Coral Castle build by Ed Leeds Scallon. Something that you should look into later. It's actually kind of connected to this in a way. Because if you're running a rotating wind and then a counter rotating wind, you're taking the 2 and you're mashing them together using a compression of those 2 fields. And I believe that's exactly what was going on with the PMH and Gerard Morin motor. Just saying.
And my rodent coil. That's actually one of the secrets is what you said, putting it in series.
Yeah, and the rodent coil has counter wind in it just by its very wraps in that.
Right, without the interference pattern.
Yeah.
Right, so technically the rodent coil is like a 13-filer coil.
Yeah.
Or it can have variations on that number, but it's a large number. It's at least 8 turns or more, 8 individual wires or more simultaneously wrapped, and they are all put in series in the configuration that is suggested by Marco Rodin. Now
there's actually there's a variation on Rodin's design that I'm actually using, which is 2 channels. So you put 2 separate channels in series, so they're lying on top of each other, but the 2 channels aren't connected.
Yeah, that's actually an ideal configuration, and you and G should definitely talk about that. So he can tell you about a 2-coiler split setup where each coil is effectively still bifilar, but
But like you said, there's different fractals, different scales of the design that look different.
Right, and so in Rodin's design, you have an enormous amount of parasitic capacitance.
It's not ideal.
But that's
kind of the ideal geometry. But I know personally, Jordan from Alchemical Science was speaking with Marco Rodin, and they came to the conclusion that the geometry is close, but it's not the perfect geometry yet.
Okay, well, let me explain it this way. Imagine that you could maximize the factor that you actually care about, the total inductance, to maximize the strength of the magnetic field. What if you could increase your inductance by a tremendous amount, but almost completely eliminate the parasitic self-capacitance?
That would be ideal. That would be absolutely ideal. But I'm still learning about the rodent coil, so
this is where Gerald has something to say, because Gerald is winding a very different kind of coil than the rodent coil.
Oh yeah, no, Gerald is. I consider I call him the Lord of the Ring.
And so in his configuration, what you're specifically looking at, which I don't know if you guys have gotten into it or done the explanation on star coil designs, but you have two conductors that are taking, in general, the total total net vector force and magnetic flux path through the Lorentz transform is still going to act like that thing is a solenoid coil, like it's a round coil. You'll have a north in one part and a south in the other. And the great thing about a star coil is that you can change the geometry, is therefore changing the length of each conducted path. Each conductor path is a straight line, and it has a parallel conductor running next to it in a bipolar configuration, so that each straight line acts as a single inductor and induces a current into the second line.
It's interesting you say that it is able to produce both poles, because something that the researchers that I'm following in the footsteps of, Daniel and Erica Nunez, they said they weren't able to produce a north pole. But recently on stream, I was messing with the frequencies and power level, and I actually was able to produce a north pole, but it wasn't stable. Like it wasn't even between the north and the south oscillation, if that makes any sense. It was
At
like
this point, we
south,
can
south,
produce
south, south, and a north.
Like, I don't know if you've seen the earlier part of the show. I've been using oscilloscope magnetometers and a variety of other equipment to measure these fields in real time. It's so much better than a compass or using a cell phone to try and take measurements.
Yeah, I plan on getting an oscilloscope soon. That's really a necessary part of the next phase, honestly.
Yeah, you don't necessarily have to have an expensive one. The probe is going to be the key here when measuring magnetic fields. You want a probe that has an extremely fast sensor. You could use a tri-field rectified coil arrangement to produce some kind of a sensor that you could simply rotate and get the perfect field geometry for maximum gain. Of course, there'd be almost no way to calibrate the damn thing, but you would be able to see your signal on the scope and tell whether or not it was higher or lower than some other part of the experiment. So at least you would get some comparative analysis.
We do appear to be getting the maximum efficiency of 155%, which is, I think, is pretty decent start for the coil. But it's not as efficient as the researchers that I'm following have.
Now, when you say 155%, do you mean 155% efficiency, as in a 1.55 COP?
So yes, so it's getting it's doubling the voltage while maintaining and slightly increasing the current.
Do you have any pictures of this?
I've got videos on my YouTube channel. We've done experiments live on stream. I got I had old multimeters, and then I got new ones, brand new ones that are specifically designed for the frequency ranges I'm using, just to make sure, and I put an output and an input circuit that was the same exact components, with the same exact energy going into both, but they're not connected. I'm using a stereo amp receiver so I can control the power evenly. It's a very basic setup, but if you go on Beneficence TV or YouTube/Beneficence TV, you can see how I did it with I think the video is called 155% efficiency with the Rodin coil.
Yeah, I'm just curious how you do your math, because when it comes to COP,
well, like I've explained it,
if it's right.
The numbers could be slightly off, just because multimeters, they're not exactly, some of them aren't exactly 100% accurate, but apparently this one has been calibrated. So and
your frequency ranges though too, and that's a huge part of the thing. Like, okay, so
you don't see the input circuit in this video though, so but I do have an input circuit, and it's not connected to the coil. It's the coil's in channel A output of the stereo, and then the reference circuit that's not connected to the coil is in channel B of the stereo receiver. So we got the same amount of power. I even tested it. Same exact amount of power going into both circuits, only the one with the coil is getting more power. And you can see when it's in its frequency range, the multimeter doubles the voltage while maintaining the current, but with outside of that frequency range, it's less on the output, like it's usually is. So it's really interesting. That right there is me demonstrating no pole, where that you do have a magnetic field. There's also a clip in here where I demonstrate the monopole. And recently I did find the North Pole. It's in there. It's probably very, very tightly packed though. But yes, I have a do-it-yourself guide. So if you're interested if anybody's interested in how I did this and want to try to replicate it, if they have the ability to do so safely, definitely check out the description that has the link to the guide in there.
I like your work, Ben. I think that Roden was wrong in a lot of different ways, but I like your work and what you've done.
I appreciate that.
Yeah,
No, I'm not saying Roden was completely right, and I'm not saying that I believe him entirely, but I'm following in the footsteps of really the Nunezes and what they claim to have achieved. And so far, everything that my research has led me to is concluded that they were telling the truth, and it's remarkable. Just go on Breakthrough Energy Movements. I think it's 2017 conference where Daniel and Erica Nunez speak. They have some remarkable things in that presentation that they give.
Oh yeah, I've seen almost everything Daniel Nunez put out before it was stripped off the internet. In fact, I still have in my
I'm so jealous.
system a whole bunch.
I never got to see all that. I discovered them after their stuff got erased from YouTube. So I had to kind of piece together this. I had to kind of reverse engineer what they were doing.
I've been around since they started watching Roden and their first meeting with Roden, and when they started the POE and the whole 9 yards. I was in the whole beginning of the internet or the YouTube explosion in 2008 when Thomas Bearden was just kind of putting out some stuff. Bedini was putting out a lot of stuff, and people were getting involved, like Mike Powers, and lots of people were building all these coils and getting involved in this.
There was a huge like not that long ago, like 10 years ago, people were building these, and then like a lot of people just stopped.
Well, I think my issue with Roden is anytime there's a geometrical coil, his name is slapped on it. And that's just not true at all. He makes very specific coils wound very specific ways. The geometry is completely different than, I'd have to say, 80 to 90% of the stuff that's out there. And I'm not faulting.
Real quick, I just wanted to add an addendum here, which is in the description, which people can't see if they're watching the video. I am still learning this, and this is the first time I've actually built anything like this. So I got the waveform wrong. I was reading it as a sawtooth. It was actually square wave. So, and I did update the do-it-yourself guide to reflect that and add a comment on there. But it on the video it says sawtooth. Just ignore that. It's square.
Please don't get me wrong, Ben. I love your work. Like I said, I ain't dissing on you at all. I think.
No. I take that as a large compliment considering what you've accomplished. So. I'm just a newbie in all this. I didn't honestly think I'd be able to get it to work. And when I did, you can ask my girlfriend, I woke her up. I was like, I screamed. I was like, woohoo! It was one of those moments where I was just like, what? What is going on? Is this doing what I think it's doing? It's pretty incredible. So, and that's like a rush. It's an adrenaline rush, and I kind of want to do it again. So let's build more. I want to see more people building these coils. They're not that difficult.
Well, I've built, like I said, 175 different geometrical coils. And
yeah, I want to get into some of the different coils that you built because I want to try to replicate some of the different ones.
Well, I was just about to say, I'm sorry, what is it? Magnetic. I apologize. I don't know your name. I'm just getting into your work, so but the imposed Merkaba, I think I've never seen a coil like that before, and that I think has something different going on than what Ben's got going on, which is different than what I got going on. But they're all basically they're all in the same principle, I think. And they're
all on the precipice of fringe science. I mean, you see
yeah,
all these distractions on the news with SpaceX and Tesla, and like that's all distractions. This is where the real science is. This is where the real industrial revolution is going to be happening. These areas.
I think what I'm trying to say is one of the key factors, or two of the key factors in all three of these systems are spin and compression, right? Whether it's charge density or time compression, call it whatever you will, refractive index. I'm not sure. Like I said, I'm still working on the theory when it comes to my system and everything else that's out there. But these three systems seem to have these three things in common, and they all do different. They have different qualities, but they all kind of do the same thing. So it's just interesting to me. That's all I'm saying.
Mm-hmm. If you've seen the documentary, I've been planning on streaming this, and I can't do it on YouTube, so I'll do it on my Twitch channel. I can stream documentaries and movies and stuff. If you've seen The Lost Century and How to Reclaim It by Dr. Stephen Greer, and I know what you'll say, he's very controversial in some areas, but regarding free energy, his research in that area is spot on. And this I highly recommend this documentary for anybody interested in free energy devices and the history of its suppression specifically. And they talk about the three areas of promise for free energy devices, and that's plasma physics, torsion physics, and ball lightning, which is basically the same thing as plasma. So.
All right, guys, let's get a little bit back to some of the stuff here.
Oh, he was muted. Yep.
I was just going to say that the other thing they mentioned is the only way it's ever going to get out is open source.
Yes, exactly.
You do.
That's why I released the do-it-yourself guide immediately. That's why I open sourced everything immediately. I think it's key. It really is.
So real quick, I want to know what's going on here. I'm going to play the video. So just let me know what's going on in this.
Okay, this was one of the early simulations that I did in 3D Studio Max, where because I was just seeing three coils, I put the vortex in. They're all pointing the right way, these space warps, and release the particles. And all I would get was this broken bike wheel, as I used to refer to it. And when it comes around, you see a bit of a figure of eight. And then somebody put me right if I'm wrong, but I heard somewhere that if electricity gets to one end of a wire and it can't get out, it goes back the other way. So therefore, in my mind, it was creating a counter-rotating field, which is where I did the other simulation and released the particles with six vortex, both two on each axis, going in opposite directions, and that creates that creates the Merkaba out of the balls, out of the particles that I've released just in a 3D simulation using physics simulation. And it was just for me, because I'm not a scientist, but what I did notice in the core of it, there are particles that can't get in the middle. I don't understand it, but it makes sense because that's where I fix the ball, the magnetic sphere. And that, that's where it spins, So is there some kind of compression going on there? I don't know.
Is that Mercury?
Sorry, no, that's just particles released in a 3D environment in 3D Studio Max, and there's vortex space warps, and there's two of them in counter-rotating fields on each axis. That's my later experiment, and that's all they are. And when you release the particles, the odd thing is, because they're built, those vortexes are representing my wires on my machine, you see. And
so that open space that you're seeing, I know this isn't the scientific term of it, but I have that in the center of my coil. I call that the null zone. Right in that spot, there's no magnetic field, there's no electrostatics, there's nothing. It's null. That's why I call it that, but I know that's not the scientific term for it. But yeah, I would think it's a result of compression.
Yeah, but I was just overwhelmed by the fact that it was creating the shape of the Merkaba, which again, you've got to think a little bit deeper about it, haven't you? When
Yeah,
you see
that's an
these
amazing
things.
simulation. That's awesome.
Yeah, that's really cool.
But it's just finding people to talk to who can think a bit all over the place and sort of put your head straight. Because when you're experimenting on your own and you start to doubt yourself and wonder if you're just imagining things, but you're not.
When
I
you think
They're all
understand
so
completely.
practical.
when you think outside the box, you got to make sure you're not in an echo chamber. You're absolutely right.
Yeah. Yeah.
Yeah, absolutely. Now, one of the things I learned as a calibration technician for 8.5 years in the industry is all about the kinds of crazy errors and mistakes that are easily made when taking measurements. Equipment errors, user errors, stray electronic fields, other contributing factors that one wouldn't even think about, like temperature compensation for certain conductors. When I was initially training to be a calibration technician, we had an assessor in who ended up later buying the company, and this assessor, he asked me a series of questions, to verify that I knew what I was doing as a Caltech. And one of the things that he did, which was particularly interesting, is, he had 2 leads shorted at the end, red lead, black lead, just to 1 meter wires, connected to the input of a high precision fluke digital multimeter with 6 digits of resolution. And he had it set to the lowest range. So what he did is he hit null on the leads. He took out the positive lead. He held it in his fingers for about 10 seconds, plugged it back in, and the meter showed about 350 millivolts. And so he instantly asked me, why is that voltage there? Explain what's going on. And so we had a long discussion about electromotive force, about triboelectrics, about thermodynamics, and a variety of other factors. And, so without getting into the story all too deeply, it was funny to see that you can just simply hold a test lead, heat it up by a couple of degrees, and it'll generate a voltage, just like a thermocouple junction. And it's just something that's kind of overlooked, but measurement errors can come from anywhere. So the real thing is, does the apparatus actually work? And so what you're doing, Merkaba Magnetricity, is physical experiments that don't need to answer that question in a less direct way. You actually have a physical apparatus, either works or it doesn't. I mean, that magnet ball, it could seize up or stop spinning, but if it spins and it gets going really quickly and it interacts with the mercury, then it's kind of like a black and white cut and dry situation. So
yeah,
experiment is key.
Yeah, Jeremiah had to set me straight on a few of my meters that I was misreading.
At least we found the problems, right? Because
yeah, we did. We did.
You didn't bring those problems to me and look at with 8.5 years of experience because you had no idea. Like, you could tell that there was an issue. You brought them to me because you knew there was a problem, and that just tells you right away. Like, if you've got a suspicion, you've got this sneaking feeling in your mind, like something is wrong with my measurement. Chances are there probably is. So take a deep look in your measurements, and sometimes that takes just as much as the experiment does in order of design and just backwards engineering how you took that measurement and what kind of contributing factors could be there. But if you work it all out and you're like, nothing could possibly explain why I'm still getting what appears to be a force, so, or a weight loss, or literally anything else, or an extraneous extra current. If you're dealing with double the voltage and you have the same current, I mean, that's as Benefactor was talking about, like, that's pretty much in that regime of over unity where we are seriously considering trying to do tests and experiments to verify
Right.
and validate that. Right? We would want to check phase angle. We would want to make sure that what we're looking at here isn't just an anomalous measurement error. So
Exactly.
here's
And that's part of the reason why I built the reference circuit as visual confirmation, just to make sure, because I couldn't trust the multimeters. Like you said, I might need to consult with you to make sure, what I'm
I'd be
seeing
glad.
is what I'm seeing,
Yeah, I'd be glad to tell you anything that you need to know about your measurement setup, and if you wanted to go on a private video and just show me what you've got connected, I
Yeah,
can
like
tell
at
you
a later
every
point, that would be
specification
good.
about all your meters.
For sure.
So no, the whole thing is there's this problem. You have what's called effective power. Effective power is the best term that I've currently found, and I got it directly from Tektronix technicians that told me about precisely which series of oscilloscopes could measure effective power. So let me explain what that is. Effective power is the real point-to-point measurement. If you take a single cycle, let's say a 60 hertz AC sine wave, and you break it up into 10 million pieces, and you measure the current and the voltage at each point between those two pieces, and you generate a measure in watts. So you stretch that out. So you got these 10 million pieces, and you measure every single one between the current and the potential. You have what's called effective power, because you've taken the thing, you've divided it into the finest scale. You have exact measurements. They're not averaged over time. They're not compensated like what a multimeter does. It averages. A multimeter will take, say, for example, 10 samples a second, or maybe 100 samples a second. Or if you're using a good fluke multimeter, 1,000, 10,000, even as much as 100,000 samples per second with a handheld multimeter. But that's with fluke. That's when you're talking RMS. That's when you're talking really high accuracies. But an oscilloscope is going to give you thousands of times more data, and one that can actually measure effective power will give you the true input-output watts. So if you have 100 amps and you have 0 volts, how much power do you have? You've got 0 watts, because you've got 0 volts, and 0 times 100 amps is 0 watts. If you have 100 volts and 0 amps, how much power do you have?
0.
Exactly. And
So
so,
multiply by 0, I get a 0.
So if your phase angle between your current and your voltage completely nullifies out the delta between your current and your voltage, you're going to end up with basically no power. And so you can measure the two independently. You can say I have 10 amps and I have 10 volts, therefore I've got 100 watts, right? But if the phase angle of the 10 amps and the 10 volts is out of phase by exactly the right amount, then you're going to basically have like maybe only 1 watt, 0.5 watts, maybe nothing if they're perfectly out of phase. And so that's the catch. It's
but like the free energy community, I'm just kidding. I'm kidding, guys.
Well, the Nunez method specifically, I believe, works on the principle of 180 degree phase shifting the two channels. You got energy flowing in one direction and energy flowing in another direction.
Yep, and that's key. But you also have to have a circuit that brings it back 180 degrees and turn it into real power.
Ah, I see what you're saying. After the fact, after that's like
right. So here's the thing:
or whatever.
Instead of considering this like two parallel strings that are both completely synchronous with each other, you have to have a signal that travels down one side and travels back on the other. It's got to take that full path, and it's the time delay that it takes for it to take the path which generates your phase differential. And you can tune that by adding external components like external inductors or external capacitors to slow it down or to speed it up, depending on which way you configure it. But you can change the resonance of a system by using external components, and to perfectly tune it in, say if it's a mechanical motor, like a magnet motor, you could tune it into a specific RPM to get the maximum gain factor. or if it's an electromagnetic coil, you can use a set of external capacitors attached to a perf board and just bridge them as needed in order to tune that specific capacitance and get the right resonant frequency. So for whatever you need, you can always tune it. And that's what Tesla really was key at. Tesla's big discovery was he understood how to tune the systems in order to make them respond with the highest amplitude possible. And we should really be focusing on the same thing, whether it be the Graviflyer, the Gravity Lifter, or any of these other systems.
Well,
Yeah, he's paying more attention to the geometry factor as well.
Right, exactly. The geometry is critical.
I got a question, and it kind of goes back to what I said about Merkaba magnetricity and bend system as well. I did a video, I'm not sure you've seen recently, Jeremiah, where I just used my signal generator from my function generator, and I put just the signal at 10% duty cycle on my primary, and I did the exact same on my secondary, and I lit a bunch of LEDs super bright. So my point is, with Merkaba magnetricity, he said it's run in series, and if it's in series clockwise and counterclockwise, kind of like what Ben's is that not voltage going against current, kind of like one signal crossing the other, creating a third signal? Almost like interferometry. Am I explaining that correctly, or?
Well, okay, so I unfortunately have to make it even more complicated to answer your question.
Sorry.
Sounds like an interference pattern.
So to answer your question, the gain factor is coming from the cross-sectional interferometry of your conductors due to their geometric configuration and the angle that they are crossing. You have a certain amount of capacitance, but your inductance remains the same. That's the beautiful part about a star coil that's wound with layered stacks that keep rotating, is that layers don't end up adding on top of each other, so that net capacitance can't travel down in the longitudinal mode and couple to each next conductor on the layer up. And
Exactly.
That's the main key, is you've minimized your capacitance. You've reduced it down to about the maximum that you possibly can achieve while still maintaining a density geometry. And so here's the funny thing. If we convert your geometries in terms of a 24-point coil into a series of stacks without saying any numbers, you can jump a larger number of points to use a different length of conductor, a different length of antenna, and take up more space, creating a gradient geometry as your coils are stacked. And the gradient in the magnetic field energy that's concentrated as it's changing over time with a very fast back EMF impulse has a direct effect on the space-time surrounding the coil. And this is where the weird stuff starts to happen, right? Because now we have an effect on the space-time around the coil. What happens to the rate flow of time in terms of epsilon and mu as they are modified geometrically and twisted within the flux of this coil's collapsing field? It adds cyclically.
You picked up on something that most people haven't. Not only that, let me give you one more. If you were to take a series of my coils and the way that they're counterwound, if you went from primary or from secondary to primary and then primary to secondary, and you were to do that in series in a loop, and you were to take a tube and run it through every open core, you would create the most efficient particle accelerator ever known to mankind. That's a theory I have. Never done it, never will. But
wait, sorry, repeat that one more time.
So
well, don't say never will, because technically, okay, you've got the bell.
Oh, I believe anything Gerald sets his mind to, he can accomplish, man.
He knows what I'm talking about.
Yeah, I know what it rings. Let's just say that.
But no, repeat that just one more time. I need to hear it one more time.
Okay, so if you were to take a series of my coils, because they produce a rotating magnetic field in a linear fashion, and you were to wind them from secondary to primary, and then from secondary to primary in a series configuration, and you were to take, I'm not sure how many we would take, but you were to run them in a circle with a tube through all of the open cores, and you were to seal that tube, you would have the best particle accelerator known to mankind, most efficient, I would say, because I can.
So in the tube, what would you put, like gas that you would ionize?
Yeah, kind of like the EPG, Stanmeyer's EPG, how he worked his system. I believe that if you were to take a series of these coils and build an EPG like that, it would be just absolutely mind blowing. It would be next level.
Crazy. Yeah, no, I'm definitely, and that I don't think.
If I could get
How
together
hard is it to get? Oh, I'm sorry.
like
Go
you
ahead.
guys, if I could get together with a team like you guys, get Nathan out here, get Ben out here, Jeremiah, even Merkaba Magnetricity. I'm trying to get as many people as I can together. I think we could accomplish our goal within a year. I really do.
It's probably not
We
that
have
unlikely.
some of the smartest people here. Oh.
I'll start the camp for a second. So, yeah, I'm working on an interesting project right now, and it's not directly related to what you're working on, G, but this is the early version that I have. It's a wrapped toroidal core that's made of standard silicon iron or transformer steel laminations, and it's got 6 individual coils around it, and they will fire in sequence, 1 coil on at a time around a circular path in order to create a traveling eddy current that moves through the core, effectively creating a soliton. Now, the soliton can't exist on its own because once the core is polarized in a certain axial direction as the field travels around, it will stay polarized. So we use an external solenoid coil, and this is a bifather winding, in order to pre-polarize the core laminate material that's inside this. And so what happens is the iron domain nuclei inside this core are going to stand up in neutral position in the upwards direction, because this coil is going to polarize them with a north on the top and a south on the bottom, causing them to stand up in the same direction as the center coil. But as each of these coils sequentially fires around the outside, they will tilt that field that's standing upright, and they will twist it to follow the core. And so we'll have this traveling wave front where we've got a twist down in one direction and a wave front with a twist up in the other direction, and it'll sort of move around the core. And what this is going to do is create a tilt in the local gravitational constant, because it's saturating the refractive index. But of course, the problem here is that we are using transformer steel, so that's not good enough.
So what is, for a layman like me, what is the refractive index?
Okay, so the refractive index is basically what determines the speed of light in free space. You know how gravity tends to bend light?
Right, and the speed of light isn't constant, so it changes.
Right, so the 2 variable factors that are most affected by the presence of gravity are epsilon and mu, and they are the electric permeativity and the magnetic permeability of free space. Now, even within general relativity, space being considered completely empty with no structure and no substance, it still possesses these 2 factors. And so they can be modified, and if you do modify epsilon and mu, you can use only positive energy to create a warp field. And Alcubierre didn't try to solve this problem. He used a negative energy or negative refractive index caused by negative mass in order to produce the opposite potential warp in the front of the craft. But Lenz came along later and solved the problem mathematically showing that you could use only positive energy with differentials due to the regauging factor of the vacuum and produce a warp field using positive energy alone. Basically, you could use a set of antennas, a set of high-power radio transmitting antennas to produce a warp field. Now,
Wow.
there's actually a couple of examples of exactly this, and they show it operating and show it producing force. These two examples are PNN, or propulsion non-Newtonian, as translated, which is an Italian company that produced a warp field antenna that they are saying is due to purely a Lorentz transform effect, and they can't explain the time variant factor that exists in this antenna. But basically, when they turn it on, it starts to produce force after a couple of seconds, and then as they leave it on for longer, the force that it's producing, even though the power input doesn't change, it continues to grow higher and higher and higher. The same thing happens with David Perez system. He originally had the company Quantum Electrodynamics. I forget what they're calling themselves now, but
That name sounds familiar.
yeah, David Perez had a warp field antenna in the early days that he was working on, and we finally got him on the Alternative Propulsion Engineering Conference that we started. And what he's got now is a pretty fantastic system that can just about lift itself. He's using spring scales, or a homemade spring scale kind of setup, in order to measure the amount of deflection that he's getting on this antenna as he powers it up. And it has the same exact effect as propulsion non-Newtonian, PNN, that when you turn it on, it doesn't instantly produce a force, but as you leave it on, it produces more and more force. And
Is there any time dilation effects that you know about?
Yes, there is. David
That's
Perez
interesting.
tested it with a laser interferometry setup and looked for a wavelength shift. And in that, he was able to demonstrate that there was indeed a temporal shift in the way.
So if this might play into this segment right here, but I am currently releasing a 60-minute video, a Divine Science special on a real-life flux capacitor. I'm not going to spoil it, but I think you guys will really enjoy it. I'm going to release it Saturday at 8 o'clock Eastern Standard Time. So I think that you'll find a lot of valuable information in there.
Man, too bad we can't get a preview of that, because I have two flux capacitors sitting and have been over there called solid state electric.
I do have a trailer, but it will be released early on Facebook. So if you want to see it early, I'm going to try to release it either tonight or tomorrow on Facebook. But that's for members, and it's 99 cents to join.
The two of you have flux capacitors. I'm going to look for a DeLorean.
Yeah.
I gotta get in on this, man. Come on now. My daughter goes 88 miles an hour. I think we're going warp speed, dude. I keep telling her we're not time traveling here. We're just trying to get to the supermarket, you know?
Just really, really fast.
You guys remember that wild story of this dude who apparently connected some kind of output of a car ignition coil on one side to an antenna on the other, and electrified the outside of his car, and allegedly claims that he time traveled with this setup?
I would love to see it. I'm surprised he's not dead.
I want to try it. Never mind.
That's interesting. I never heard of that.
I was cracking up the first time I read it, and I seen it actually translated from a Russian article. I have to trace it back to figure out where the heck it came from. But yeah, apparently this dude sets up the ignition coil as like an antenna transmitter and electrifies the rest of his car with the opposite potential, and claims that he time travels like a couple of minutes or something like that. And he's driving down this slope.
I don't know. It's possible. Yeah,
I'm not going to say it's impossible. Okay, I'm not going to say it didn't happen. I'm just, I was cracking up with the story. It's still like a very ridiculous but entertaining story.
The setup sounds very simplistic.
It might be a shocking. It might be a shocking experience. Who knows?
Well, he also proposed it as a security system for the car. So.
Oh my God. Yeah, you're time traveling. It feels like the lights are going past you because the cops in the background pulling you over, man. And you're going down the hill. It's it's like smoking it out and trying to drive, man. It feels like you're in
You go
warp
park
speed.
your
It's
car at
all coming
Walmart,
past
right?
you.
And you every time you show up at Walmart, like, and you park your car, you come back after 30 minutes of shopping, and you come outside. There's like this pile of like 6 or 7 people that are just laying on the ground around it, and you're like, "Oh man, not again! I got to drag them out of the way to get out of my parking spot." Probably not the best idea.
It's like a community taser.
Just don't install a time machine on a Tesla. It could randomly time travel without you knowing.
Nah, this is the correct core material. This is something called super malloy. I've not got it quite terminated. You can see that the end of the lamination isn't pulled in, but I've got Teflon tape that should be arriving in just a couple of hours. So what I'm going to do is actually layer these laminations from one core to the other. This one is a blank core that I 3D printed thanks to Simon's work. And so I'll be respooling what's on this core onto this one, but there'll be layers of Teflon tape between. And at the center of this core, you can actually see the metal termination for the end of the lamination. And so if I Teflon insulate all the layers, I effectively have a solenoid to generate a net H field that I can use for magnetic polarization. And
Is that what they call a circular magnetic field, electromagnetic field, and a circular with a circular construct?
It would be, yeah, it would be a circular magnetic field, yeah.
It's circular, but it's not rotating. Is that correct?
Well, actually, it wouldn't be rotating if it was just continuous. But again, that's why we have this set of coils where we fire from one to the next.
Oh, no, I get that. I meant the other one. Sorry. I know what you're working on. There's a lot
No. So we have a static, right? You're right. This is not a rotating field. So this is a static field, but induced into the core, even though we have the field vectors pointing upwards, if we pass a current through this lamination material, they'll tilt sideways when the current starts to flow around the core because of
so it'll tilt in the orientation of the current.
Right. So as they twist, they don't just simply twist and then bounce right back. If you get the frequency just right, you can get the twist wave up to such a high amplitude that what happens is it twists, and instead of bouncing, it actually flips. It goes the other direction. So it starts to rotate. But what it'll quickly do is it'll want to try to neutralize its net momentum. So instead of rotating and flipping around like that, what it'll start to do is a precessional motion. And with this precessing motion, you end up with a net type of field that is carried in the pure momentum of the relativistic mass increase due to the atom momentum of each individual electron shell that's precessing and the nuclei of those atoms that are being carried along by that electron shell that's forcing the nuclei to precess. So it's doing this little wobble thing. And inside of that wobble, it carries a tremendous amount of momentum, and that momentum is actually carried around in a circular motion. So it tilts the gravitational force that this core experiences, in theory, and causes it to weigh less and less and less until its mass actually goes negative.
Would you consider that like some kind of centrifugal force?
You could consider it analogous to that, but
analogous. Okay, so it's not.
So
just imagine it like a centrifugal force, but it's not exactly the same.
Right.
You're looking for a gyroscopic motion, correct?
Yeah, in this case, we're looking for if you had a symmetrical north and south on the bottom. What if you could create a really, really sharp pinch point between this north and south that were evenly distributed on the top and bottom? What if you could pinch them together at just one point? So if they're crossing each other and you can suddenly cause them to pinch together like this, you got this kink instability. And if this kink is traveling around in a circle,
Is that when you create like a monopole?
It's effectively acting like a monopole.
Like a pseudo monopole.
Yeah, exactly. A pseudo monopole in the axial direction.
You're compressing it in just the right way, so you get just the outflow of ether energy.
Right. So because the space-time compression is so tremendous, what happens is you increase the energy density in the local space, you spin up the local nodes at the Planck scale, and so the aether actually expands outwards, and the speed of light is modified, and it moves faster in that region because the nodes and their distance is expanded in that region, and so you end up getting a redshift onto the outside, which means that you're absorbing energy from the outside into the system.
Right.
Your and mine work, or
Yeah.
your work and my work are very closely related. They're not quite the same, but closely related. I love what you're doing, Jeremiah. That's awesome.
Yeah, you know, they should really cross paths, and most of this stuff is all about crossing paths anyways, magnetically, electrically, or otherwise. So
Exactly, and that was my point about Merkaba, magnetricity, and Ben's work. We're all doing the same thing. There's like this underlying truth amongst all of it, right? Just like in, I hate to bring up this reference because it dates me, but in Ghostbusters, what do they say? Don't cross the streams. And then in the end, what do they do? They cross the streams. Okay, so like, I mean,
But not only that,
how
Gerald,
they win the final battle is they cross the streams.
not only that, Gerald, I have to commend everybody here for their work because we're going against the mainstream. We're going against the grain here. You know, we got people, I'm sure I have people who are telling me I'm insane. You know, I don't know what I'm talking about. You know, that's impossible, stuff like that. And, you know, we need encouragement, you know, and this is what these.
Sorry.
So originally it was under the you know, the name It Is Possible, and then I later changed it to Break the Limits. And I'm currently using exotic propulsion on my channel, but I don't post even probably 5% the stuff that I do. So I have a tremendous number of experiments. For example, like that 6-coil system that I just showed you, here's the step sequencer for it. So it's just basically each step it moves through and fires a different coil. So only one coil is on at a time, and the back EMF from the last coil's phase collapse meets the front or the forward EMF of the next coil's phase build. So the two end up creating this sort of pinch point of magnetic fluxes right between them, and because of that sharp transition in magnetic field, you get the spin polarization. And
so that's your H wave right there.
Right, that's your H field.
So hold on,
that's cool.
How different is that than the other one we saw? A gentleman just died, and he was using a field to turn it on and switching, and it would only go on at a certain time and then switch off and on. And he was trying to get rid of the I forget the back force, EMF or whatever he's looking at of the actual magnet. In
Probably
doing
anti-Lenz law would be my guess of the term.
Yeah, and then John something or am I
Well,
close?
you got John Bedini was the guy that did.
No, different.
Okay.
Guy had a long hair. He just passed away probably about a month ago. Maybe a little bit more, but it had to do with the Lenz's law, and he had this big giant machine that was in his garage.
Is it Joseph Newman?
4 foot by 4 foot. I don't think it was.
That's Joseph Newman. You're talking about it's like a magnet motor that's been turned inside out, correct?
Let me look it up. I'll look it up while we're talking right now.
I maybe I'm wrong. I think that's what you're describing. I think Ben's
That's the only guy that I know who has long hair.
No, we're talking about somebody different here.
Yeah, you know what? It must be because Joseph Newman passed away quite a while ago, actually.
Oh, really? Oh,
yeah.
huh.
So.
Yeah, I don't know.
Yeah.
Somebody new to me. Yeah. No, it's okay.
I have no idea who it might be.
Who?
Nathan will get to the bottom of it.
I'm looking it up, man. I have it saved somewhere, and you guys go ahead. I'll look this up. It was just a really interesting.
No, I hear that. I got 5 terabytes of scientific videos and PDFs and file. It's insane. So sometimes when you're looking for something, it's really difficult. Like, I'll give you for instance, Nathan, the Steinmetz book. All I have it on is video. So I'm reading the book very slowly, like you can scroll through the video. But it's basically like, that's all I have of it. I don't have the actual PDF form of the book. So if you want that, I can email you that.
Yeah, I love one of those ebooks that reads it for me so I can sit and do work while I listen to it.
Oh, I hear that. That I don't have. I got
Get
one.
Speechify. Get Speechify. That's good for that.
Can you run Speechify with PDFs?
Yes.
So
Run
like if
Speechify with anything. Even if it and it should run, but if it won't, just copy and paste it into the Speechify program and it'll read it.
because I got like T. Henry Morey's book, and I got Walter Russell's book, and Hutchinson's book, and by George.
Yeah, that's what I do. I just use Speechify for all my audiobooks or for all the books that I want to read to me.
That's awesome because you know what? It's really hard to read them all.
Yeah. Yeah, it is. It's hard to find time too when you're so busy, you know, trying to pay the bills and all that. I understand.
Pay the bills, experiment, and build devices that you can sell. Like right now,
Yeah.
I'm working on a chain bar lift. Well, multiple chain bar lifts in one system. So
I still think we could all start a business. We'll think of something. I think a good viable business might be starting with selling coil frames, but who knows? You know.
I'm working on opening a business that lowers the solar footprint. So rather than like say you have 5,000 watts of solar panels, well, most people don't have enough roof for 5,000 watts for one, and for
Right, so you increase the efficiency of the
not
photovoltaic
so much,
process.
more like the way of the design on how it's displayed. No, that's not quite the right word. So most people put solar panels on the roof. Well, I've got a system where it unfolds. And
Oh,
because
so it's also it would be less um
it's very
tightly and more
compact.
compact.
Yeah, and in fact, the way that I designed it, you can stick it on. I wouldn't recommend a roof that's a bit high. You could stick it on a flat roof shed. You could stick it on a trailer, a boat, like what's the word I'm looking for? Like a barge. You can stick it on a barge. There's a lot of things you can do with it, and it literally raises like a tower, and it turns slowly with the.
I honestly, if you find an investor, and I think you will eventually, that's a great idea. So I wish
Yeah,
you
I've
luck
already
with
built
that. I think you're gonna do good with it.
I built a small prototype and tested it, and it worked really well. So now I've purchased. I spent quite a bit of money, but it was worth it. I got 720 watt
Yeah.
solar panels. They're huge,
Oh,
and
wow.
so the big prototype is going to be an unveil very shortly.
Yeah, it's an investment, you know, and we all make them. They're calculated risks. It's all.
Yeah, and hey, if not, doesn't matter. I'll have solar power for my house.
Right, yeah. So there's always a good side. But no, I think you're doing good with that, and I think you'll succeed because that's a good idea. And a lot of people, especially the people who have money and don't want those unsightly solar panels like to be unsightly, you know, have the option of folding them in and all that.
Yeah, you can fold them in at night, charge your batteries during the day. You
Mhm.
know, then that way you don't have to worry about like preppers kind of think in the way that in a grid down scenario, people are going to be looking for you and they see the solar panels are coming to your house. Well, what if you could just hit a button and your solar panels fold down? Nobody knows they're there.
Right.
know,
Yeah,
Added
no, that's exactly.
Yeah.
Yeah. No, that's great. No, just keep thinking of you know, good ideas like that. I think you'll succeed with whatever you put your mind to. Honestly, Gerald, you're really smart.
Appreciate that. I'm not so sure, but I appreciate that.
No, I am. You gotta have a little faith. Gotta have a little faith.
Well, I got a lot of faith. I just need a couple pennies to rub together in order to make some of this stuff happen.
Yeah, and that's a problem, you know. You got to learn how to market yourself, especially if you're doing it on YouTube. It's triggering the algorithm's tricky. Trust me, I've tried everything under the sun, and you know, I think I'm finally starting to get and understand the algorithm. But once you learn it, you know, and learn how to trigger it, I think you'll have a little bit more success.
I remember this guy. He
I
sort
found
of,
it.
yeah, he sort of disappeared.
He
Right
died.
after
Oh wow.
he
Yeah, I've
died.
never seen this guy. Who is this guy?
It's an interesting system.
Defeating Lenz law. I have a chapter in this in the Practical Guide to Free Energy Devices that we went over.
Yeah, so as this device turns on and off things, switching on and off the coils there, and then it goes, turns it off, and it goes to the next one, picks up. So you never get the back EMF to hold back the magnet. It continuously pushes it on and on and on. So it goes really fast as a motor.
Wow.
It defeats Lenz's law.
Yep.
That's why I was saying the switching, it's almost the same thing. In what Exotic was doing is it's
almost
switching.
identical, actually. The way that he's switching each individual segment there, just one at a time, in order to pull that thing along. Although he's switching technically both sides opposing, so he has 2 shifts in the local refractive index. But in my case,
So left and right are off, and then center's on.
So
Right.
if he wasn't defeating Lenz law here, what would it be doing? Just going back and forth and almost stationary and not moving all the way in a circle?
Yeah,
Well,
but that's
the
sorry.
catch is that you have a field conversion in your solenoid coil that chases the flux through the core that's orthogonal to the electric field being produced by the core. And so because the solenoid coils wrapped around the core are just producing the polarization within that core material, the core material's field is orthogonal. And so the way that it interacts is a little bit different, and it sort of breaks the phase angle coupling coefficient between your driving coil and your stator coil.
So like from a layman's term, you would basically say he's pulsing it so fast he doesn't give the system chance to have the magnetic field build up enough in order for it to slow the system down, so no back EMF can be created.
Right. What he doesn't want to do is specifically force the domains to stay in a tilted position. If you take even a laminated iron core like what he's got, or a laminated transformer steel core like what he's got, I believe that's what he has in that system, is a sort of toroidally wound core. It could just be a solid core. In either case, what you'll end up with is a bunch of domains that can twist, and if they get twisted into a new angular position, they'll stay polarized, so they'll hold their magnetic field. Sort of like if you hold up a magnet to that core, and then you put a compass near that point, you're going to see whether or not you held up the North Pole or the South Pole towards the core. It'll hold on to the flux to some extent. So you want to try to keep it just below the threshold where the flux stays stuck. And during the back EMF impulse, you depolarize it so that you end up with a really sharp wave front.
That's actually one of the principles I use in my coil. Very fast pulse rate and very, very, very fast not rise time, but lower. I basically pull the energy out of the back before I can.
So you're pulsing it so fast, you're not giving it time to oscillate backwards. It's just kind of
exactly. And because of that, I'm giving it also a path of least resistance at 180 degrees out of phase, so that I can pull it out before I restart the next pulse.
All right. So specifically, what he's doing is even speeding it with a square wave, or even at 10% duty cycle, the rise time is always longer than the fall time. And what that means is the net energy differential in terms of the stress energy momentum tensor of space-time is always pointed inwards towards the system. It acts almost like a gravitational force, because on the back EMF impulse, it radiates electromotive force and expands the local aether density, and that will cause anything that's traveling in towards it to blue shift, and so it can gain energy from the external environment. And so he could technically, I mean, if he ran it correctly, he could get the thing to cool down or do various things like that, I would just suppose.
I have, but it remains to be peer-reviewed by you and a few others. Like I said before, I'm now at 39 coils to give out. I'm not sure if I have that many on the list yet, but there's quite a few. that it's going out to. So very near future, I'm praying. We'll see.
Well,
Have
you
to
know
buy
what
me
it
a
will
lot of
take.
multimeters for that thing, man. I wonder if they make a giant one with like 10 of them in it.
Oh, they do.
Oh, they do? Oh, I gotta get me one of those.
Yeah, me too.
Yeah, they go under the category of data acquisition systems, and
Gotcha.
you'll find them with capabilities of measuring temperature on many channels, voltage, current, whatever. And so what generally they do is it's sort of a cheap skate move, but they'll sequence through each of the channels and take a little sample for however many you have. If you have 10 channels active, it'll take a sample of each of them for 1/10 of the time, and it'll display you that number. And so for the rest of the 90% of the time, it'll miss it. But if the sampling frequency is much, much higher than the oscillation frequency, it's not really a problem. But the closer that they get to each other, the more the error increases, and they can get to a point where the measurements are basically worthless. But they do sell them. They're available, and they're not insanely expensive. They're not unaffordable.
Are they considered scientifically acceptable? Or is it better to have like...
No, they're considered scientifically acceptable if you get them calibrated.
That's fair.
Yeah, with any good scientific paper, you're going to have some kind of traceability. I mean, I've seen a lot of papers that do crude experiments, and they just put out these papers purely because they came across something interesting, and are like, so I'm a student at whatever university, MIT, Cambridge, wherever, and I stumbled across this interesting thing. Let me write this paper about it. And so that kind of stuff comes out all the time. We've had it with graphene and metamaterials. We had it with graphene. We had it with the LK99 alleged room temperature superconductor. I replicated that stuff, and so did Michael Perrone and a few others. And we've got our own opinions on it. I won't get into. But anyways, yeah, I mean, these little ideas pop out all the time. But the question is, can we actually put them into some kind of functional, replicatable format? And so the idea of the scientific paper is, I'm going to tell you what I did and exactly how I did it, what equipment I use, and then you go figure out if this has any validity. If a scientific paper has that or contains that level of specificity, it tells you what equipment was used and how the test was done, then it can be independently validated, and it becomes scientifically valid at that point after peer review, because there's a possibility of peer review. What I'm seeing, though, from academia is terrible. And it's a shame, because you would expect this from the fringe community. But instead, no, mainstream academia is providing a huge number of papers that are purely mathematically based, with no experimentation done and no proposed experiments.
We call that, where I come from,
Yeah.
and paid for.
Yeah.
Absolutely worthless to any of us in the lab, unfortunately.
Yeah,
I shouldn't say absolutely worthless. I would take that back, because the truth is, I've read a lot of those papers, and some of them do contain some interesting ideas.
We do a lot of talking about, like, theory can only bring you so far. You have to actually experiment with your ideas, before you start to learn and develop your theories, or else you're just going to be stuck.
Right, exactly. And
Yep.
a lot of this stuff has just led to dead ends. For example, Fran Aquino is an interesting case. I guess he has somehow collaborated with doing experiments, but I've replicated a lot of Fran Aquino's proposed diagrams. And when he writes a paper, he proposes a physical construction of a device and provides you the voltages that you need, and the spacing, and the level of vacuum, or whatever conditions, and whatever light source. He tells you about each of these factors. And so I've actually replicated many of his devices, and I can tell you for sure that they do not do what he claims they do. The level of force is several orders of magnitude off.
Wow.
And it's a mathematical error. I can kind of see how he made it, but I'm no mathematician, so I'm not going to get into where the error was made. But Yes, it's several orders of magnitude off. The force is extremely weak, but it does have the same phenomena of being a cumulative effect. Why is it cumulative? Is a question that when we can answer it as a community, we will understand how to make as much anti-gravity as we could possibly ever desire. We will understand how to bend space and time when we can accumulate energy in a local space. That will
I
be
would take that one step further and say that free energy in general is freedom. You know, it will allow us to break the binds that have chained us for a long time.
absolutely.
Yeah, I think what Jeremiah is trying to say though is when you get anti-gravity, you have to have free energy. You can have free energy without anti-gravity.
Oh yeah, for sure.
Yeah,
Yeah, that's
to accomplish
a must.
anti-gravity, free energy is part of it. It has to be.
But this is an exciting time because I was just talking to Nathan, you know, like when he finally gets his Graviflyer working, we're gonna build or he's gonna build a big one, you know, and we're gonna fly around the solar system.
I can't wait to see that.
Yeah.
Get me out of here.
Yeah.
I'll record it on video, you guys leaving, and then I'll build mine.
Dude, it's gonna be so cool. Hey, what's going on,
Crypto?
What
Finally
up,
made
guys?
it. How is everyone? Great conversation. I've been listening.
Yeah, I can actually hit present now. Let me try to see if this is going to completely crash my computer.
So
It's
for those
actually
who are
quite-
just listening, Crypto Alchemist has showed up, aka Bernie. Sorry, I just had to do that.
Do it while the audio still works. Okay, so here we go.
Oh, hold on.
see.
We got some presentation popping up. You want me to put that up?
Yeah, put that up. I'll show you. This is so much earlier in the show. For those who missed it, I spoke about trying to communicate with the deceased Nikola Tesla and ask about how he built Wardenclyffe's tower. And what I got as a response was a series of diagrams in my mind, and I proceeded over the next day to build it. And instead of the normal purple white sparks that most Tesla coils produce, you're going to see in this video the contrast of the white in the spark gap and just how red these sparks are shifted into that wavelength. And so I'm going to go ahead and play this video here.
Wow. Is it interfering with the camera? Is that what's happening?
It's my bandwidth.
Oh, it's your bandwidth. Okay. I was like, is it interfering with the equipment? That's
No, it
crazy.
actually
I've never.
it froze on my end too. Actually, the video froze on my end, but you can
I've never
see
seen a
here,
discharge pink like that. Or is it red? You said.
yeah, it's pinkish red, and I've seen it get fully red and actually go orange as well, which is super fascinating. So I'll stop my share for now because that's obviously not working. I'm going to try to find a picture of the orange spark just because my video seems to be incapable of actually.
Now, what was the orange spark doing again?
Well, the thing is, the output is coming from an aluminum terminal. I also tested it on a stainless steel terminal, and on a steel terminal does the same thing every single time. It's always the purplish red spark that turns orange at the base. And the reason for why it gets so damn hot and why the energy is concentrated so high has to do with the voltage or the ionization potential of the atmosphere. So normally it just ionizes nitrogen. A normal Tesla coil will ionize nitrogen and other atmospheric gases that are easier to ionize. And so that's why you get these brighter colored sparks. But if you can actually ionize the oxygen and then break apart the molecule, you can ionize singlet oxygen and you can get a reaction. And it's
Right.
extremely in the red spectrum.
Hold on.
It's easier to ionize the noble gases rather than with the stable.
That has to do with the stainless steel?
No, it doesn't. That was my main point, is that it doesn't matter whether I use an aluminum terminal or a stainless terminal or a steel terminal, it does the same thing every single time, which means that this is not metals flying from the terminal. This is actually an atmospheric phenomenon. And that's how I ruled it out, is by using different terminal conductor metals in order to guarantee that I wasn't getting vaporization of metal particles.
Gotcha. There's a specific reason why I was asking. It was Alexi was said to use stainless steel in his all threads instead of what do we have now? Something else, some kind of metal coated with zinc or something.
Yeah, I think he's using galvanized steel for his center plate.
Yeah. So that was just, if it was something different, I'd like to know, you know what I mean? So if there was a change I had to make, I'd do it.
Oh yeah, I definitely hear that. Well, I have so many pictures of this damn thing, but can't find the one. I can't find the one with the red spark. Well, there's no easy way for me to scroll through it. I have to actually open up each one independently and then click share screen every single time. So I'm just I'm bumping through them. Yeah, for some reason, Mac has this built-in function called Quick View, and you can simply view a video or an image, and you can scroll through the entire folder that way. But unfortunately, there's no way to share Quick View because it's a built-in secure feature. So in order to actually share a video, I have to open that video in QuickTime Player, VLC, or some other video player on a Mac. So I'll go ahead and present this too. You can actually see that it goes red at my fingertips, which is close enough.
Okay, I don't have anything yet.
Not yet.
Oh, thought I was missing it or something, man. I'm going crazy.
Kind of like our ball lightning videos, Jeremiah?
Right. Yeah, we did some pretty good work on ball lightning. Okay, so I'll play this. And so those are my fingertips.
Cool. You must have some nice holes in your fingertips.
No, you don't really feel this at all, which is really interesting. It feels hot. It feels like it just kind of feels like you have a really bright light shining on your hand. And it does make your nerves twitch a bit, but that's because there is a huge amount of potential there. And so as it contacts your skin, it actually turns into current, and that's why you get the color change in the arc.
And this is from your Tesla coil?
Yeah, this is from the magnifying transmitter that I built based on the designs that popped into my head when I asked Tesla how to build the magnifying transmitter.
Well, let's hope that Tesla's on
awesome.
my side this coming Monday, because I'm going to shock the living daylights out of myself with this. I'm going for it, man.
He's going for it.
We're doing some high voltage, man. I'm going to hook up my Tesla coil. So is that AC or DC, so I don't kill myself?
Yeah, that's all AC, and it works pretty well, so no major.
All right, here we go.
Are you going to live stream that?
Nuts in his garage. What's
Nathan,
that?
are you going to live
Please
stream
do
that?
live stream,
Yeah,
so if
that's
you
one
do
of
get
the
zapped, we
realities
can
here.
call an ambulance for you immediately.
There you go. Call the ambulance for me, because, man, I'm going to light it up. I got all kinds of good electronic toys in my garage, man. I'm going to light some stuff up.
Yeah, it's about time for me and my girlfriend to go back over the CPR stuff. And
Yeah, for sure.
Safety first.
You better call a medic
Yeah.
first.
That's
let
why
me grab this thing real quick. You guys will love this.
I don't know if you noticed, Exotic, but when I did the testing with the neodymium sphere, I grabbed my hard hat. I didn't know what it was gonna do.
Oh, my God.
That's funny.
Yeah,
know, hard
no,
Oh, man.
like I was afraid it was gonna fly up into the ceiling.
Wow. Yeah, I'll tell you what, one hand at a time. Keep the other hand behind your back, or play pocket pool, do something else, but don't get it anywhere near that.
Oh, the
other
one hand
end.
rule. Yeah, I was just reading about that. So you put one hand in your pocket to eliminate accidentally touching something to complete the circuit or whatever.
Okay, let me tell you a story, okay? I built a voltage multiplier to my AC flyback, okay? 24 volts going in. I made the mistake of grabbing one side and grabbing the other. Okay.
Oh boy.
Oh man, I lit up like a Christmas tree. My hair started frizzing a little bit, man. I was like,
Chevy
oh
Chase?
God. I sat down and rethought my whole life. You know, it was just awful. It was nothing like the
wow.
little shock you get once in a while. You go, ow, that's okay. No. This was like life changing. It reminded me of the time I was playing my circuit breaker out back, and I had put the top of it, I laid it down on my head, and I was playing with the breakers like a moron. Okay. And I took some kind of a voltage return that zapped right through my skull into this thing and made the loop. Thank God it did, because if it just stayed in my body, I'd be dead.
Do you wear any kind of do you wear insulated boots or anything like that when you work around high voltage?
Nope.
Or no. So I know some people, they'll wear like insulated boots or insulated equipment. I wonder if it even helps though.
Well, we're not talking super high amps here with the volts. So, I mean, we're in milliamps with volts, so it's relatively safe, but not really. But
So it's still gonna push it back a little bit.
yeah, it would be different if I had higher amps into it and then high volts. Then it's a death ray. It would just kill you. There's no getting around that. You're just dead.
Yeah, right now it's just gonna bite you and bite you hard.
I had a friend who grabbed he grabbed an extension wire at work that was exposed, and it fried his arm to the point where it just like all the nerve endings were just constantly in pain.
My dad used to tell a story. He worked in the mines, and when they would set up a new mine, they had to run all the cabling and the 220 and stuff. Him and his buddies, they used to do this as a joke. I never understood that this was funny. But if you grab your buddy's arm, and I don't recommend this, let me say this right now, nobody in public, please do this. You grab your buddy's arm and you grab the 220 line really quick. You'll throw your buddy 5 feet against the wall without really hurting him. But boy, it's a kick. He said he had it done to him 3 or 4 times. So
boy, it's a kick.
Buddies. I don't recommend it. I'm just saying.
What's an explosive shock between friends, huh?
Right? They must have been good buddies, I guess.
I'd say.
Oh,
I don't want anybody to shock me.
My dad miswired the shop out back. It was a 2,400 square foot metal building. So every time he touched the doorknob, you'd get shocked. He misplayed something on the neutral or the ground or something. And he thought it was the funniest thing because he was used to it. So he opened it up, no problem. With the rest of us, you go near my shop, you're gonna get zapped. You can't play with my toys.
Here's a defense mechanism for you.
Oh man. It's so great. Yeah, voltage is fun, man. Oh man, did I ever have fun lighting some stuff up with some high voltage like a year ago? God, that was all I was doing was lighting everything up. If it came in, I don't care what it was trinkets in the drawer, man, I lit it up. So
I hear that. When I first started experimenting with the big coil that I show all the time, I used to load capacitors, like just little 25 UF 100 volt capacitors, and I'd get it right up to about 85 volts. And then I'd wait for my wife to come walking down the hall, and I'd just tap it and the thing would explode. It sounded like a shotgun shell. She'd jump every time.
I'm surprised you're still alive after that.
I'm surprised I'm still married. Never mind.
Oh man. My wife's gonna buy me a fire extinguisher for Christmas and my birthday and every other occasion after what she sees next week.
I'm gonna buy her one for her birthday, just so you don't burn down her house and she has a husband and stays alive, right?
Maybe a fire suit to go along with it just to save him after. I don't know. I'm just kidding.
Oh, I got an emergency shut off for the power, man. So if she comes in and I'm half dead, there's a big red button.
Nice.
Be flopping like a fish on the floor. You come in and visit me. Hey, here's your dinner. Oh my God, what happened to Nathan?
Yeah, all you got to do is grab a handful of this thing. This is a
Can
nice
we
little
put that on
bipolar
big
test coil.
screen?
Oh,
I don't know how to do it, Crypto. Do you?
Just at the very bottom of where there's like each of the screens of the presenters, you just like click on it, I think in like the top right or left corner, and it'll say solo layout or highlight.
Okay, I don't have that. Hold on.
Oh.
Let me solo layout.
There
we
you go. See? Looky what we have there.
So it's a basic bipolar Tesla coil, built on a classic wooden frame. We have two arc terminals at the top. I've got it connected to an ungrounded lithium-ion battery, 8.4 volts going into it. And this is a DC-driven coil, so it's basically the first 2 of 3 stages of the multiplier. And because it's a DC-driven coil, it does generate a plasma rectification at the terminals, but you'll hear it. And I apologize ahead of time for the sound down there between those 2 shiny screw terminals. Here and here is the spark gap. So I'll turn it on for a second. So you can see the spark gap.
Very nice.
So I'll go ahead and connect that wire.
Yeah, that's really cool. That is really cool.
And I'll spread the terminal distance out. So again, sorry for the sound. I know this thing is probably the most annoying sound in the world.
Plasma.
But the weird thing is, what you can't see on camera is the smell in the air. So
The ozone being
it's
created. Right?
ionizing a holy load of ozone right now. And the reason is the extremely high potential. So when the primary coil impulse fires, it's coming from this big red capacitor bank right over here. And all of these are ultra-fast polypropylene capacitors, and they're ran in a parallel chain configuration. And then I've got 2 compensation ceramics just to deal with the impedance mismatch of the primary coil, because I have to go a full turn instead of a half turn. And so these capacitors take care of that. And then it's being powered by a DC ZVS driven circuit that has a full wave rectifier that's right here. You'll recognize that blue capacitor ceramic and the high voltage diodes that are surrounding it as a very crude full wave rectifier. And, overall, it works incredibly well. I mean, the key to this coil working so well, the thing that I discovered is exactly what we have read about years ago. Thoriated tungsten electrodes allow the system to run cold. So this spark gap, you would expect the spark gap here to get hot while it's operating, but it stays virtually at room temperature. And I've had circumstances where if I balance the impedance and the phase mismatch of the secondary just right, so how can that possibly happen? How can we lose thermodynamic energy to 2 thoriated tungsten electrodes that are 3 millimeters in diameter?
You must be getting you must be accessing the vacuum and creating cold electricity somehow.
Right, which is basically why I was looking at this simple setup and like, oh, I can hook a battery to this and demonstrate this for you guys. And
well, that's really cool. That just shows you there's multiple different routes to get to the same solution of free energy. There's so many different ways and so many, and even basic circuits, and that's something that I learned recently through the works of John Bedini and all that stuff. But it was mind blowing. Like, scientific consensus the mainstream, way that we are taught, those little rules that people like to ignore that create instability in the system. And then no, Tom Bearden comes out and says, no, you want that instability and you want to use it.
I don't know if it's related, but when I've been running my machine, the main wires, the big wires, the coloured wires that make up the pyramidal shapes in the middle, they get warm when it first starts up, but the longer I run it, the colder they get. There's no heat there eventually. I don't know.
So it's an endothermic reaction, and it's taking heat out of the environment, correct? It's cooling down the longer it's running, you say?
Yeah, the wires don't get hot after a while at all. There's no temperature to them. I've not obviously took proper readings, but just to the touch, when you first start running it, when it's slower, it's quite warm. But as the ball speeds up and it's been running a while, there's no heat in those wires. It just made me think of it when you were talking about that.
Sounds similar to like the Searle effect generator and a few other magnetic disk systems.
Yeah, we find that we can pump in a tremendous amount of current in some of these circuits, and they just don't get hot, which is really counterintuitive. I mean, you can calculate out the resistance, the effective impedance of the circuit using copper conductors or whatever conductors you're using. We've tried aluminum, we've tried carbon nanotubes, we've tried quite a number of different types of conductive materials in order to optimize these effects, and there's a lot farther that we can go with that. That's a Pandora's box that you opened up and realized that the conductors that you use can massively increase the gains on the system. So outside of that, though, these anomalous effects, you've got to pay super close attention in order to spot them. A lot of them you wouldn't even notice, or you could just write off being noise or a measurement error, and they'll simply go away. I'm surprised that Gerald isn't talking about more of what you just brought up, Merkaba.
What, instabilities?
Exactly, because that's entirely how your system works.
Yep, 7 different instabilities. You put them all together, and they manage to dynamically multiply everything in the system. And those are the things that electrical engineers, excuse me, purposefully do their best to get rid of in a circuit or in a system itself. Like you said, noise, right? Well, when you're trying to get rid of noise in a circuit, I like using that noise. It's all part of it. Know how to use it, so to speak. It's like a
It's interesting, you would think that at least them two together and say, we're trying to increase efficiency, but we're not utilizing any of this noise that we're creating in these systems. It seems like you would want to try to tag that as one of the inefficiencies in the system right away. Like, how do I use this?
I blame it on years of doing things one way, and that old saying, if it ain't broke,
it goes against the grain. Yeah.
You know what? I was hated since I was born.
Right, well, like the system is broken now, and we already are the ones going against the grain. So let's take it all the way.
What drives me
is the only way I know how.
I hate to tell you all, but you have, and I know the size of your channel, Bernie, and it's the first time I'm meeting Merkaba. And I know you, Benefactor, but I don't know subscribed yet, so shame on me, but feel free to post a link in the chat so other people can if they want to. Anyways,
sure.
Known you guys for a while, kind of have an idea about how big your influence is. A lot of people working on this stuff, and some of us actually have achieved success in the categories. Talk about it because there's a lot of baggage attached to that success. Sometimes it takes years of research just to reach the point of full understanding, and then you're kind of stuck with this conundrum of, well, do I tell everybody about what I think I've discovered, about what I believe is going on, or do I continue to research this and try to fully understand it before I talk about it?
You know what? I'm of the mind like this. I really don't give two flying fornications what academia thinks, and I couldn't care less if it was proven one way or the other. I'm lighting lights in my house and charging batteries without moving parts, and I don't really care if there's a theory put to it or a mathematical calculation. Proof's in the pudding, and I got chocolate. So
at the end of the day, you have the results of it, right? You're benefiting from it every day.
And I'm actually building multiple devices. Every day I'm finishing a new device based on these principles. And I'm going to share it all. There's no benefit. It was freely given to me. I'm freely giving it. I don't care. The way that I see it, if everybody has free energy in a grid down scenario, nobody's coming for mine. I don't know if that's self-serving or not. I apologize.
I would just say get it out soon. You know, if you're going to get it out, get it out soon.
Oh, I have a dead man switch on. Don't kid yourself. There's 37 people on that list, maybe more. I'll just say 37 confirmed. Anything happens to me overnight, everybody's getting. So I'm not worried about that. I'm just sort of working it one day at a time. But anybody and everybody who's working on this that gets to a level where they're seeing anomalous effects, you should have more than one dead man switch put in play. You should have a digital, you should have a physical. There's a few things that people should do to protect themselves just in case. So let me say this. I'd never in 100 million years commit suicide. Ever. It's not in my belief system. It's not in me. So I'm saying that right now. So for the record, that's it. That's all.
Right there with you. I think there's things going on in all of our projects. I don't want to release anything until I reasonably know what's going on. Like, it may do the effect you want it to do, but I'm not telling you about it until I can have a firm understanding of what I'm doing and how the flow got there. Because that's the first question everybody asks, isn't it?
Right,
Absolutely.
exactly. And especially with your system, you're working with a lot higher voltages, and potentially dangerous scenarios. So, you don't really know
Not
what's
so much
going
high voltage. It's switching. It's changing fields.
Yeah, like I'm not saying I don't understand my system. I've written lots on my system. I just don't care if academia understands it. You know what I mean? But yeah, you're not wrong. It's better to understand.
I don't think academia really understands like much at all these days, so it shouldn't be the top concern, right? It's like, if it works, teach others how to build it so it can work for them.
Honestly, my concern with the academia goes about this far. I try to do my research mindfully enough where I use the correct terminology in any kind of disclosure that I'm going to present. So I want to use the same terms along, but whether or not they approve or disapprove of what I'm presenting, I could give one less about. So the evidence stands for itself, stands beyond theory, and I don't really care what anybody has to say beyond that point, but I do try to use the correct terminology because I want us to be able to at least communicate on the same plane. It's important to learn the terms. I know that academia is this big bane for a lot of people, and myself included in that, because they've got their very closed loop, closed-minded thinking paradigms, and trying to step outside those bounds, you can get tremendous pushback.
It's a
Yeah.
click. You know what
It
I mean?
is, exactly.
Like, I understand, you know, to speak their language is something that's important in order for a barrier to be broken down between the experimenter / inventor and the academic world for understanding theory and the physics behind it. I totally understand that. I can speak the language if I chose. The issue is it's their language, and it was purposefully, I don't know what you would call, I wouldn't say purposefully, but it was built throughout time in order to separate themselves from the regular, everyday, average guy. And if that wasn't done, maybe people wouldn't be so predisposed to looking at academia like a foreign force, so to speak. And I don't think that way. Don't get me wrong.
You're not wrong about that. You're really not. I mean, that's a lot of people out there. You know, your home experimenters, folks like us here today. They look at these academic articles that are entirely propagated with mathematics, with no relation to reality whatsoever, and it's just these impossible figures that don't make any sense, and they've tried to use as many symbols as they possibly could because, well, it makes them look smarter. So I get that whole prospect of it, but at the same time, to learn the language, they're not okay. I'll reword this. You can use the academic principles currently available in the mainstream to prove these theories and dynamics that we're talking about. It turns out that these principles do exist and comply with many conventional theories, especially the big ones like general relativity, Lorentz transform, quantum electrodynamics, and others that we could get into. But you can fit what we're working on into these already recognized academic principles. Even if they're not recognized by the academics themselves, it's because they don't understand the text they are reading. If you understand it better than they do, which is not particularly hard to do, you just simply read through it and say, well, I've got a real world visualization of what this looks like, and I can derive these other principles that are part of this equation from that visualization. If you can visualize in your mind, and you've got a huge advantage. And you can see these effects happening in real time in your mind. So this is one of the things that the group of us like to do, is get together and, you know, we sort of co-visualize some of these phenomena and then discuss the implications of how these effects interact. Cross-field interactions, wave interferometry, scalar and Hertzian potentials.
Hey guys, real quick before we go any further, Merkaba is going to take off. He's much later than we are. It's like 8 hours ahead of us.
Oh,
wow.
So sorry, Merkaba. Amazing work. I had to say that. Thank you very much for sharing.
Thanks, Gerald.
Yeah, thank you.
Thank you to all of you.
Amazing research.
Yeah, I'll be back. I'm definitely coming back to one of these. I've enjoyed.
We look forward to it. Yeah.
I'll put you on the list, man, to give you an invite for every one of them.
Brilliant.
Thank you
very
so
much for your time, guys.
Yeah, thank you very much.
Thank
Catch you later. Bye now.
Bye. I'm probably not going to stay on too much longer myself. I got to finish up that Divine Science editing. Almost done. Got to finish that up tonight.
Yeah, me too. I have to jet too. I was going to say, I agree with you, Jeremiah, but I like what Nathan does. He likes to fry it and find out.
I've got no problem with frying it. You know, the new circuit that I'm putting together with the 6-phase sequencer is all 3 terminal blocks for each individual MOSFET. So when they do blow, which hopefully I blow a couple of them, you know, because I'm going to push it to that max power level, then they're easy to swap.
Do you guys, or Nathan, do you mind quickly just playing the Merkaba video of the design of his for my channel, as we're also, I went live on my channel, but I've yet to cover his generator, where You've actually gone quite extensive into it the last few episodes on your channel and on these think tanks, and it is something else.
Yeah, I'll put it up right now for you.
Thank you, sir.
Matter of fact, we can play a couple of them if you want.
Oh, this is cool.
Right, and just so many of us making our own designs and coming up with anomalous breakthrough results.
That's
I
one of the
know, it's
coolest
an
thing I've
exciting
seen when
time.
I saw it.
Where did you find this, Nathan? Just on YouTube?
To be honest with you, man, I was on Facebook and he contacted me.
Oh.
And we got
Even
talking
better.
back and forth, and he showed me this, and I was just in awe. And I'm like, okay, everybody's got to see this.
Yeah, this is definitely unique. It's definitely unique.
Oh, I should have asked. How are you doing the frequency sweep on that?
That's fast.
So he doesn't have a motor spinning that. It's like magnets and coils that are causing the spin. Is that correct?
So
Those
hold on.
orange coils and those green coils are causing the rotation.
Wow. That's wild.
And he's putting an amplifier into it. It goes into the little coils around it, and it's making frequency inside.
So no actual motor, physical
Nope.
mechanical motor going in. That's all rotation from coil fields, electromagnetic fields
That's
causing
right.
rotation.
Yeah, in crypto, you'll love this. He uses ancient history as the design for this stuff. So
That's awesome.
when you look at his work, he's looking at flow works, you know what I mean, in ancient symbols and stuff like that, and all that kind of work.
Yep.
And I can show you that in a little bit.
Wow.
But
Yes,
that's where he's
please.
getting his designs from, the triangles and the, you know, I mean, different shapes. He shows a shape earlier in the video of what he's actually doing. It's Merkaba, is what he says.
I love how he has a ferrite magnet on the bottom, but it's so far away from the actual spherical magnet. There's no way it could affect it unless that Merkaba design's actually doing something.
Right, exactly.
So here, I'll show some more of his stuff so you guys understand.
Please do. This is wild. The sacred geometry. It's designs. It's two-dimensional blueprints of 3D things, right?
Yeah, this ties in kind of to Bob Grainier's research.
Yeah, so this one right here, he's going to tell you how fast this thing was going. Top speed. Now, he says that every one of the frequencies you have to put in one at a time on the coils in order for it to work. So each one of them is doing something different to the magnet in the center. I would have loved it if he could put a little ball on it, a little line on there, a little line just to show where it's at. I don't know if you see it at that speed, though. So in this one, he's using copper ball inside of that little piece right there. The piece of plastic in there, and I'll turn it back on so you can hear it. Sorry.
A little bit, let's say, looking in there earlier, but I think it's probably gone now. But when we bring it close to the spinning magnet, stealing a lot of the thunder, the magnet's slowing while the copper ball's increasing.
Okay, I'll pull up another one. Oops, sorry. Still not as good as you are at this, Bernie. So I'll figure it out.
Sorry, I've got to run, but
You're learning,
it
right?
was a pleasure.
Oh, Jeremiah, I needed to talk to you, but fine. Savage.
Oh yeah, you know how I am.
All right, Jeremiah, thank you for showing up, man. It was really cool. You guys did stuff on the early part of the show with
Love
the
you, JP.
with all the Mercury was awesome.
You know, we love to do the experiments, right? That's who we are. We are a community when we try to support each other. And when there's an interesting topic like this one with rotating Mercury and gravitational effects or electromotive forces, we've simply got to investigate it. You know, it's
100%.
practically an enigmatic compulsion. We have to do it.
I'll have to review that. I only caught the back end of it, and that's awesome you came on.
So I will catch everyone later, but thank you so much for the great show, Nathan. And
Right on. Thank you.
you
Yeah,
guys
thank you,
catch
Exotic.
it easy, and hopefully I'll see your future shows and determine based on the title if I'm going to join. So I'll see you then. Take it
All right.
easy.
Yeah, we hope to see you. Bye.
Much love, Jeremiah.
All right, so let me pull up another one here for you guys. I'll just pull up his channel here in a minute. He does the Mercury experiment, but he also, I'll show it to you right now. So look real quick at the ends of the Mercury and look at the divot inside those right now. It's actually pulling in and sucking in like a vortex. So you can see it on the right and left side of it.
That's interesting.
So they definitely got some way cool experiments. So, all right, guys, go ahead and talk for a minute. I'm going to pull up his channel again and get this thing going. Hello.
I was just stepping out for a cigarette for a moment and then coming back. I was like, play the video so I can step out for a smoke. Then I promise I've got lots to discuss as soon as I'm done.
Oh, man, right on.
It was a quick video, Bernie. That's all.
Yeah, sorry about that.
Well, shoot.
It looks like Ben just disappeared. Maybe while running that Mercury, it was like poof. I'm kidding. I kind of wonder though, if you had a Mercury chamber in the middle of that Merkaba, but it was shaped differently, kind of like a tube in a tube, and the inner tube would be shorter than the outer tube so that the Mercury could climb up the center tube, fall into the outer tube, and then come up from underneath and climb back up again. Kind of like a magnetic field line excursion. I don't know, just a thought. I wish I had enough Mercury to try it.
Yeah, me too. Yeah, this one, he changed the center out, and he's actually got it going inside of this little piece of 3D printed material here. And he's pulling, I would imagine the lights are connected to it, and it shows it lighting up as he goes.
Wow, I don't think I've seen this one.
Remember, he was talking about the different types of LEDs as well.
Yeah, because they light at different voltages and at different currents.
Yeah, it's just so cool.
Yeah, I guess that's solid state. That's kind of like what I've been doing. That's awesome.
Yeah, well, I think he's still got the magnet in the center, but it's producing the field, and you start to see it. I kind of wonder what would happen if you put the Tesla meter in there and just to see how much Tesla force is in there between the actual outside frame and the rotating magnet, because you're getting two different fields.
Yeah, but is he rotating the magnet right now?
Inside the little piece of.
Oh, he is. He is.
Yeah.
Okay, so it's on mute or something.
Oh, yeah, I put it on mute. I'm sorry. I'll
No,
play it
that,
again.
that makes sense.
It gets loud. There you go.
Right. Okay, that's fair. Now that makes sense why the bulbs are lighting up. He's capturing that back EMF.
Yeah.
From the actual spin. That's pretty cool.
Dude, that whole design, just the way it looks, is cool. So
you're not wrong.
He's got a new one. Okay. So,
something different?
He built a second one. So let me pull up his work. He shows it. Let me share the screen on this right quick.
Awesome.
So I need to remove some stuff. It'll take me just a second. Share the screen. So this is his new machine here. Let me start it over.
Wow, look at that. He put some love into that.
Yeah, he did. I think he's got a lot more hiding under there. I'd love to see it because he's talked about the coils being set up. So
interesting.
Yeah, this guy's channel's all interesting.
Yeah, I want to see what that thing's going to produce. I just started looking at his work, but it's based on the same principles.
Yeah, you just don't have the rotating magnet in the center. All the other types of things, field upon field, is all kind of in
there. Yeah.
You might have to get with him, Joe. He has to talk to you. So I send him your channel. I'm going to send him your email if that's okay.
Yes.
Going on here, because I'm sure your work is going to cross over with his. Very good.
Yeah, I imagine it will. Looking at his system and seeing how it works, I imagine it'll cross over quite a bit.
Those little spikes every time captured in that capacitor.
Absolutely. I already have a good idea on what I can do with his system right now.
Wow.
I've already took it apart in my head and put it back. Something I've done since I was a kid. Maybe it's a really good imagination. Maybe it's, I don't know. But I can see it perfectly in my mind exactly how to improve what he's doing. What he's doing is already awesome.
Yeah. He's ahead of me, and you're ahead of me on all that. I haven't worked on that stuff in a while, man.
Yeah, but you're ahead of me on high voltage, so you win.
I don't know that I win.
No, I'm seriously kidding, but you know what I mean.
I win the booty prize. You're getting shocked a lot.
Yeah. I've gotten shocked a lot too. Not so much with as much high voltage as you, but yeah, definitely.
Oh my God. I think I see it in my dreams where it shocks me.
You definitely feel it in your sleep, right?
Oh my God.
Your body's aching and
my arthritis in my hands keeps getting worse, and I'm thinking it's from that high voltage getting shocked every few days.
Yeah, that might be it. Little inflammation there bursts.
The exact opposite from Dr. Ho's shock therapy.
Yeah. It is the opposite. It has the opposite effect in my body. I can tell you that.
Yeah.
I need Gerald's coil to heal my hands again.
I agree. I totally agree. Need to pull Zapped.
I pull some of it.
Yeah.
Hey, check this out, Crypto. You back from smoking?
Yes, I am. I'm here.
Nope.
Nope.
Check it out. I wanted to show you this because, I know you're all into this stuff. So check it out. This is where his inspiration comes from.
Oh, yeah.
So He's saying the energy swirls and it makes this pattern in there, and the swastika is just the energy
The
flowing in that
representation
pattern.
of it. I've seen
Yeah, the
several
vortex.
with that.
You know, I'd have to agree with them because I don't want to give away certain things that are in my
It's
coil.
crazy.
But when I'll say this: when you take a form of a triangle and you spin it, you can see that swastika in the form when you're building your coil. It's
That's
very
insane. That's an ancient symbol. Yeah, that predates. Just for anybody watching who isn't aware, this predates the Nazis taking the symbol and adapting it. This is very ancient symbol. It goes back to Buddhism and other ancient religions.
Thousands of years, right?
Yeah,
And
it wasn't always.
this
Sorry,
would
go.
explain why they still have it carved in so many of the different temples across Asia and India and whatnot, is because
They
it's
clearly knew something
representing
we
the
didn't.
energy of it.
Yeah, they clearly knew something we don't.
It was part of their power system, and I believe 12,500 years ago, maybe even 13,000 before the flood. I believe that they had this tech. I think that they had free lighting. I think that they had motors, electrostatics. I think they had mastered this electricity. And then after the flood, it's like starting over again, right?
So here he's trying to visualize how it goes in, and he first came up with this one right here, where he thought the magnetic field was just spinning like this, right?
Mm-hmm.
So, but a magnetic field never spins like that. It always spins in spheres, right? But on the opposite side, it pulls in the energy. And what he was saying is the energy pulled in is like this. It makes that Merkaba shape. And I wish I can go back and show you the live. I'm not sure. Oh, there's the shape right there, or kind of close to it, where he has the different triangles in it. I'm trying to find it real quick.
That's wild. How it just sucks in those particles.
Yeah. Let me see what he's got. Oh, so it's a different one. But he was saying like the spin and the different triangles and stuff like that. And this is a representation. If you put it in 3D, it's more like the I want to say Israeli or their symbol. You know what I mean? That star.
A Star of David, right?
The Star of David, yeah.
That's what his Merkaba looks like. So I'm trying to find, if you see it in 3D, it's a lot different than seeing it in 2D like this. So trying to see if he had it.
The Star of David's like the 2D version of an actual Merkaba. And what magnetic or Merkaba magneticity, I'll say it eventually properly. What he built is an actual Merkaba.
Now, I'm very impressed with this whole setup. It's very unique. It's something that I didn't think would be even possible, but I mean, clearly it is. Just with but I mean, I haven't really researched triangle power yet. You know, pyramid power. It's something that I haven't really delved into, but hey, this is really cool.
I hate to break it to you, Ben.
There's a
but
lot.
You're holding on to I wouldn't say a weaker version. You're holding on to a different version of the heart of a pyramid. That's what all this vortex tech is literally the core heart of a pyramid. If you go 1/3 down on the inside apex of a pyramid, there's a cluster of charge density that forms in every pyramid just due to the very shape and the movement of the earth itself.
Does this have anything to do with the hourglass shape that is the inside
Similar.
of the course?
The hourglass shape is a form of a pinch, right? Well, the heart of a pyramid is the form of a pinch as well. It's actually the bottom half of the circumference of the pinch. And if you go up through the apex of the pyramid and were to take the exact same size pyramid, flip it upside down, and go point to point, you now have the identical circumference of that energy heart of a pyramid and the apex above it in that secondary pyramid. So between two pyramids from point to point, one facing down, one facing up, you get a pinch in the middle of those two pyramids in that point. And then the vortex shows up on the inside apex of both. And that's what the hourglass kind of means. So the Merkaba is like a compression of both, almost the form of a portal, or you could almost consider it a wormhole in a sense, because it compresses both into one solid sphere, or ball lightning, or call it what you will. That's my theory anyway. If I'm correct, I don't know. We'll see.
I know one thing's for sure, and that is that I'm definitely going to have to consult with you when I do my episode on Joe Parr.
Sure. Nathan has a lot of information on pyramids as well.
Yeah.
Definitely do.
So yeah, I it's not going to be anytime soon, but definitely have to consult with you guys on pyramids, because I don't know jack about pyramid power or anything in that regards to what Joe Parr was doing with the shape of the pyramid.
Well, there's more to it than that. Even Nathan was, he even clued me to a piece that I was missing. So it's everybody has their piece of the puzzle. And I think if we come together and we all express it, we're going to find how it all comes together.
Well, we're going to find Waldo finally. We're going to finally find Waldo.
It's like if you take a piece of quartz and you turn it the correct way and you take a big neodymium magnet, you'll feel the force. It feels like eddy current. When you put it close to rotating magnets, it'll actually have a force that pushes against it.
Absolutely.
So a lot of people don't know that. They just think quartz, whatever. And I keep telling people, you got to activate the quartz. You have to be able to take the oxygen in there and take all of the streams in there of the oxygen and be able to magnetize them against a magnet. Then you're going to start to get a force, because think about it then. If you're getting a force of eddy current inside your piezo, if you simply can put that side close to it and then rotate the magnet, what are you going to get then? Are you going to get the piezo to light up? Is it, you know what I mean? Is that piece of quartz going to do something special for you? If you simply took a piezo disc and attach it to a piece of quartz on one side, can you get that pulse rate to push in there and get it to light up? There's just a lot of different things about quartz you should think about. And then you also have to think of how you're going to pull the energy out. Because you can spark two things together, but that's not going to give you the energy. You actually have to put it in salt water or some kind of water with fluoride in it in order to pull the energy out, because you want to put the wires in the bowl of water with the fluoride in there mixed. And in California, they put fluoride in the water, so it doesn't really matter. But what I'm saying is every time you tap it, you're going to get an energy that pulses out. You can't just pulse it through the quartz. You have to find a medium to pulse it through. That's what the Egyptians knew, and we didn't.
Absolutely.
So the salt water or the water acts like a conductor.
Yes,
for the electricity to flow out. Yeah,
fluoride is in rainwater. So when you have around the base of the pyramids, you have this valley that's all the way around it, and it's held in by a little wall. Okay, when you have rainwater in there, or you take the Sphinx right there and you fill it up with water in that little pool thing they have sitting there around it, and it goes and flows over to that other area, it'll always keep it filled with that fluoride water in there. And then actual quartz, not the quartz, the granite will pull it up inside the pyramid. It acts like a candle wick. So it'll actually keep the entire thing soaked in water, just like we have water in the center of our earth that's held in there in rock. It does the same thing.
Yeah, it's hydrophilic. That was the thing that you clued me into that I wasn't fully up on. That's awesome.
That's crazy.
We could probably set up a clear box and then basically just take a heating coil and take a piece of granite, put some part of it in water. We could suck up all of the water into it, heat it, and then it'll come up as vapor and then come back down. It looks like kind of rain on the sides. And we could keep just a whole thing rotating with changing from water to, heat to, everything else.
I do. Yeah, evaporation, condensation, all that. That's an interesting experiment.
I'd love to put a ring of high voltage around the top just to see if I can get a cloud to form.
I started building a
guaranteed
real
it will.
life pyramid that's 3 feet tall. I haven't finished it yet, and it's on the back burner right now. I had announced it on Ashton Forbes' channel. I actually got the recipe for building the brick that's the original formulation for the pyramids themselves out of the Geopolymer Foundation, and I tested it, and it's the actual stuff, and it is hydrophilic, just like granite. So so I started building bricks, and I got it about 1/3 done, and I built the other bricks, and I just have to continue to put it together and shave the bricks down and make it like pyramid shape. But when I get that done, I'd love to do what you said, get a bunch of plexiglass and maybe encase it in plexiglass and then try that experiment. I kind of wonder. That's really, you got me thinking.
The plexiglass would add a static shield or field around it, no?
Yeah.
Well,
See? That's why I want to see if it gets into a cloud.
Yeah, see, you got me thinking again, Nathan. See, we all have our talents. Yours is high voltage. I love it. Okay, yeah, we'll have to get that done eventually.
Hey, Bernie, what were you showing a minute ago? What was that?
So this guy here, I kind of destroyed it at Jeremiah's request because he wanted to see how it was built, but I need to rewrap it. It's a tetrahedron pyramid of just copper wire and aluminum foil that when I had it made properly, the majority of people that would hold it in their palm, you'd instantly feel heat being formed underneath it, to the point that lots of people felt like they were being burnt and had to drop it. And then what was very interesting is that anyone that was intoxicated on alcohol or anything, just no effect at all, as if it wouldn't create that energy or collect the energy that it used to
That's
create
crazy.
the heat.
Just with the geometry alone. Yeah.
Yeah, of
Shape
just
power.
like copper wires in there in triangular fashion on how it's,
I'm sure touching your body creates some kind of closed circuit of some kind of, but what?
or open circuit that's then collecting energy out of the static field or heat
Right,
from
right.
the environment.
Well,
Right. No, that is probably more accurate.
I think alcohol. Sorry, let me remove this real quick. I think
You're good.
alcohol pulls in all of your blood to the center of your body and tries to burn off the alcohol in your body. So you wouldn't get the same feeling you would. It's like sitting in a bunch of cold water. Your body automatically pulls everything from your extremities and pulls it inward.
Huh.
So that's probably why you couldn't feel it when you're on alcohol and why you get in accidents and you don't know that you broke your arm. But the fact that it actually makes your hand hot when normal condition is just totally amazing. Sorry.
Right? No worries.
Still trying to get used to it.
Oh, you're learning. You're doing good.
Right.
Ben, have you any new developments with your PoE coil?
Not entirely. I haven't really had time to work on phase 2, but we have decided we are going with the Bedini circuit. If you or anybody you know has I think we're looking for a 24-volt battery that's completely used up, maybe like 3 volts coming out of it. We need one for phase 2 testing. I can buy a new one, but I have to shop around for a used one that's, gonna be able to serve as a good experiment. See if we can rejuvenate it.
I've got a version of Bedini circuit you're going to want to try after you try your version, because it does something just a little bit different than what Bedini was doing. But and it allows you to gather power real fast, slam it into a cap bank, and use it as a ground or as a load.
But to just extend on what I was saying there, crypto. Lately I've been in crunch mode trying to get this video out, and it will be out Saturday at 8 p.m. So I'll send you all an invite to the premiere and all that. It's going to be really great. It's going to be about an hour long. It's going to be on time travel. So, but once that's out, it's all phase 2, baby. So.
Well, I'm gonna time travel ahead and go watch it.
Come back and tell us how
Oh,
it was.
it's good. It's good. I don't want to spoil anything, but I think I've reached the height of my production quality abilities. You see, like on my previous videos, I was kind of
Awesome. What do you mean?
80% there, 90% there. But well, I like as a self-critic, I have to be realistic. But I think I really nailed it with this one. So I think you guys are going to enjoy it.
I call it the Spider-Man principle. With great power comes great responsibility. It's true.
For sure.
All right, guys, you know what? I hate to bail on you, but I'm getting a stink eye. I got to go make supper and all that family jazz. So thank you for having me on, Nathan. It's been a great conversation. Hopefully we can do this again.
Thank you, Gerald.
Yeah.
See you
Thanks,
guys.
Gerald.
Much love, Gerald.
Later, Bernie.
Here's a picture of an ice cube with the colloidal gold silver water that I make. And you can see the exclusion zones and the fields of bubbles that it produces there. And
Speaking of that activated, I'm sorry, go ahead.
That there's I've got many of these ice cubes that's like just.
So there's no coil in there, it's just the air bubbles.
Yeah, you got it. It's just
Speaking
how
of
it
activated
freezes.
water, you gotta email me your recipe. How do you make that activated water that you drink?
I just make monoatomic gold out of pure gold anode, pure gold cathode, and salt water, and then collect the monatomic material at the base of it.
Do you have like a video where you show the process or anything written down?
Many videos.
Yeah, just when you get time, send me a couple of links of some videos of you going through the process, and because I'd like to make my own for sure.
Absolutely. And then from there, you just rinse it out a whole bunch to get the salt out. And after about 9 rinses, then I start using the colloidal water at the top there that absorbs the monoatomics as that water that you saw that froze into that ice cube there. And then I'm testing the plants with and some of the water that I drink with.
What do you mean testing the plants with? You're using it on the plants?
Yes, absolutely. I'm doing agricultural alchemy experiments with these jars of water here, some of the purple and silver gold, as well as using the white monoatomic and trying some of the blue oxidized diatomic. And as I suspected, the blue and turquoise diatomic oxidized water actually harms the plants, stunts them, and poisons them, where the white and the purple monoatomic water exponentially increase the growth rate of the plants.
So white and purple does good and the rest kills them?
So white and purple are good, and then I suspect the yellow, the blue, the green are the bad ones.
I remember you mentioning the blue one on stream was toxic. You wouldn't drink it. Would that be like something you could accidentally make?
It does start. So when you start the reaction, it produces the white monoatomic to begin with, and then about an hour or two into the reaction, then it starts oxidizing off, and after that, it goes into the other 6 colored states of transmutations of elements that Isaac Newton talks about.
It's crazy.
Hey, Bernie, there was a question here for you.
Here's some more pictures of different ice cubes with these fields. Oops, wrong one.
Oh, that's cool.
Yeah, you can see it. Wow. You can see the wave. It's literally a waveform.
Exactly.
Wow. you've captured the effing frequency.
Wow, that's really cool.
Yeah, that's insane. I mean, I'm sure it's magnified because of the ice and all that stuff, but sure, like that's a slice of time right there. That's crazy.
Yeah, it's like
Like it does it to all of the ice cubes with this water.
Wow. And that's a sign that you did it right. That waveform.
Exact, right?
Okay, so that's going to be the marker that I'm looking for if I make this activated water.
huh.
That one almost looks like a vortex, doesn't it?
Oh yeah, and often when I mix the fresh water in with the monatomic in salt water as I'm rinsing it, it will create these vortexes and spiral looking galaxies with exclusion zones of like arms of the monoatomics, then just straight water, then the monatomics, then the water. I'll get a couple
That's really
pictures of those
cool.
up to show you. And so here you can see the whole ice tray.
Wow. Yeah, you can see all of them. All the waveforms in the top. And they all look relatively about the same wavelength. Am I wrong about that, or
No, you're
is
correct
that
with that.
huh? It has to be a like a slice of what's happening, in time. That's really cool. Like a dinosaur frozen in a cube.
Yes, sorry. Give me a moment to find the other pictures if you want to put it back. So to make it, Nathan, to make it go back to the way you had it with all four, I believe it's either to the right of all of the pictures of us or right below on like the main part of the screen there. There you go. You figured it out.
Okay, got it.
You got it.
Getting better.
Exactly. It's just a learning process.
There was a question for you, Bernie. I'll ask it for you. Okay. So have you used distilled water and gold yet? So you know that you're getting actual gold and not a cascade of minerals.
Yes. Right here, for all of the ones that are just like straight first time experiments, I have the distilled water and use distilled water, and that let's see, distilled water, right? And that I found no difference in distilled water or my Canadian tap water, but anytime that I'm running it as a straight scientific experiment, I use the distilled instead of the tap water. And it's that the monoatomics I'm making is not from a chemical reaction like most Ormus practices where it's taking it out of the water. What I'm doing is I'm using electrolysis where the material being formed comes straight off of the physical metal solid anode that's in that reaction. So when I'm claiming that I'm making monoatomic gold, it's off of a 24 karat gold anode and 24 karat gold cathode. The silver, it's I use 99.999% silver maple as both the anodes and cathodes. Copper, it's copper, zinc sort of thing, right? So that there's no possible way that it's other elements in what I'm making.
But also, if it's using the transmutation process, which is what we know is charged clusters, if it's transmutating anything in any way, then it is relevant what's in the water.
Oh, absolutely, yes, and that's another part of the experiments and the process and the theory and what I'm doing and more advanced aspects of it. But this is just strictly for the Ormus monoatomic material and how to make it.
So would you recommend the distilled water for drinking, or it just really doesn't matter as long as you get that waveform.
Yeah, I would go start with distilled for sure. Then you know everything that's going in it, and that's actually especially true in areas where your water like might have like poisons or heavy metals and stuff like that already in it. 100%, because then you don't want to be charging those particles and those other heavy metals that are in that water into this ormus state.
So
That
what
makes sense.
what does this stuff do when you drink it? Just
I've been
I'm hearing about it.
I've been drinking it for 10 years now. I never caught COVID, never got no shots, was exposed to it like over 50 times at least. I haven't really been sick in 10 years. And people saying I'm looking pretty young still, being 39. I don't know. Maybe it's delayed me at 28 or 29 since I started drinking it.
Nice.
Hopefully, we'll see.
He found an elixir of life.
Potentially, right?
Cousin. Yeah, that's crazy.
We have some truly remarkable people in this group, on these shows, you know, like some really crazy stuff's going on.
With my agricultural alchemy last year, I put some of the actual monoatomic gold here next to a lettuce plant, and it grew 6 feet tall. And then all of the plants, so this is the purple gold and silver combination.
You drink the purple too?
Yeah, I've been drinking the purple water now for 2 years, and it's completely fine. And it turns purple when I leave it out in the sun and the moon. The sun for the gold and the moon for the silver. For those reactions, or if I put some of my own like saliva, blood, hair, like DNA biomass into the reaction as well, then sometimes it also forms it into purple state. But yeah, so crazy. Watering with the colloidal water, the plants grew like 3 times the size of the other vegetables that were just with regular water. And then when I actually put some of the physical gold, silver ormus next to it, it was double that at 6 feet tall.
Dude, imagine growing some crops with that water in my coil.
Right? Exactly.
Wow.
That's the goal of it.
So interesting. Man, I learned more here than I ever did in school. That's for sure.
Right? I think everybody does, including myself. It's that right. It's sharing our own knowledge and what we've learned from it. And
they tried to keep telling me how to build an essay. Man, I could have been so much further ahead if they were just teaching coils and wires and, you know,
right?
Stuff like that. We can, you know, learn how to break stuff apart. Man, that's the fun of it.
Exactly. And yeah, so I just got confirmed on Sunday. This Sunday evening, I'm going to be doing a stream interview with Kevin Hay, and he does Vancouver Island Ormus, and he's just brilliant genius, and he's been showing results of like 3x, 6x times plant growth with all of his ormus that he's been making for over a decade now, and also goes into explaining free energy, the ether, and just so much more.
Hey, Bernie, did you put the time of the stream and everything in the chat?
We are yet to figure out the specific time, but I think it'll be probably around 7 p.m. Pacific, 10 p.m. Eastern.
Okay. Gotcha. I'm still awake at that time. We're good.
Right? Exactly.
I'm in California, so when you know, I mean, sometimes it's like, wow, it's like 9, 10 o'clock. I got up at 2 a.m, so it's like, wow, like way far out of my range.
Fair, right? I'm working on being on more reasonable time zones. Usually it's like I'm nocturnal by nature, and at 3 a.m. I get inspired to finally do a stream, or it's like
I
I
noticed.
start putting it together at like 2 in the afternoon, and then it takes like 10 hours just to get all the freaking information together.
Dude, I think last week I woke up at like 4 in the morning and I missed your stream because it was like 2 hours earlier. And I'm
Right?
thinking, yeah, just a little bit earlier. I could have caught it.
Yeah, and that's something else. I'm like, instead of starting in the middle of the night, just wait a couple more hours to like the morning, and then y'all be able to join in.
Oh man.
Well,
Yeah.
we really enjoy your stream. I know your last one was really good.
Appreciate that.
Yeah, I
what
love
else?
the breakdown in metals, by the way. I was checking that out as you're using the electrolysis, and everything comes, completely destructs this whole thing, man, into nothing. It was just awesome.
Yeah, and so the next experiments that I'm gonna try, I've got a bunch of extra microwaves. I just don't want to do it around my house. I got to get like extension cords and a big field somewhere. But apparently, when you put the monatomics in with the microwaves, it actually puts it back in a solid state, and that there's been many stories of it also transmutating them into new elements of, if you're combining different elements of Ormus together, that it'll combine them into heavier, like the adding the two together sort of thing, the atomic masses, and giving you the new mass of whatever element that is.
If you cut a hole in the back of your microwave and attach a cell phone to it, you can get the camera to go right inside there as you're doing your process. And then it actually keeps the chamber intact. So you're going to get the microwaves inside of it. And you can get a spectrum analyzer in there, anything like that. It'll actually show the different temperatures and what's going on in there as well. So just so you know, for your experiment, when you get an old microwave, keep it. And if it works, cut that little hole in the back. I'll send you a video on it. There's a young kid. I say he's young. He's probably about 25 now. He does this experiment where he lights up aluminum foil with a little beaker over top of it, and he creates plasma in the top chamber of it.
Really? Okay.
Yeah. You know what? I'll look that up while you guys talk. Let's see if I can't show it real quick.
I like the sounds of that.
But the way he sets up the experiment is perfect for you, what you're doing.
Right? Oh, big time. And especially apparently there is a like I can never say the freaking word. Not even gonna try. Whatever it is, the analyzer of the light waves of what elements are, app program for smartphones. Mass spectrometry, mass spectrometer. There we go. Right?
Oh, check it out. Okay, I found it. All right. Hold on. It's playing with me just a little bit. All right. So let's share the screen. Oh, that's the wrong one. That's the right one. Okay. So, yeah. Hold on. You can see he looks like a kid, right? Like I said, he's probably much older than that by now. Let me see if I can't find the spot where he does it. So you see the little pinhole in the microwave there in the back? Right, in the center of it?
Yep.
That's where his camera's coming through. So
right, just need to make it large enough. See, that's ingenious.
Silverware, and it really didn't do much. So kind of strange.
He must piss off his parents a lot.
He's sitting in his garage with like 50 different microwaves.
It's all smelling like burnt plastic. Is that
burnt metal?
Burnt metal, yeah.
So which one's this? Oh, it's matches again? Huh.
So hold on. He's got the matches. Let me find. Oh, now he's just lighting stuff on fire. Okay.
Right.
Wow.
Purple at the bottom.
Yeah, you see the plasma start, and then he uses an analyzer to check out and see what light spectrums he's getting. This is like,
That's next level. See, that's what I need to figure out and start doing.
so he tells you how he does the trick, by the way, for the microwave in the video. So as soon as the video's over, I'll go ahead and post it in the chat for everybody. But,
Appreciate that. What elements, I guess, then?
I can look it up. Let me see.
Yeah. That's interesting because I forgot about that little factoid, putting grapes in there.
Yes, I believe blue shift to red shift, that's space-time distortion, correct? Yeah, I think so. That was a question. Pretty sure.
Oh, here we go. This one looks like it lit up. So let me share that. Let's see what this guy's doing. What has he got? He's got grapes. Yeah, yada, yada. Let's get on to the grape.
Right? Like, just how much do we need to... How much of a video can you make about grapes in a microwave with plasma without it being the grapes in a microwave with plasma?
Exactly. All right, now we got some grapes.
Wow. Look at that. That's crazy.
But the reaction's even wilder when you cut the grapes in half. It doesn't look like they do that either.
Yeah, I don't know if he's going to do that. It's kind of pushing it.
There we
you
go. There we go.
Oh wow. Yeah, the grapes like fused themselves together. Look at that. That's insane.
Where?
Oh.
Yeah, there it goes right there. I think he has it in glass.
Yeah, yeah.
That's crazy.
You got to love plasma, man. All right. This guy took forever to get to things. Sorry, I don't
guess
know about
he's
you.
actually explaining some science in there. We're just not listening to it.
Yeah. We all just wanted to see the grapes. Come on.
Exactly.
Got to give him a little grapes in the beginning to show it kind of doing what it's going to do. Then you can watch the science.
It's about time for me to hit that old dusty trail, gentlemen.
Yeah, me as well. I got my mom's waiting on me to come help her with some gardening stuff. And, well, it's the heat of the hottest part of the day is now over. And I got to get my butt down there before the sun sets. But I will be back on, I believe, with the Woo Woo Wednesday episode in a few hours with Hans Dietrich. The Sunday with Kevin Hay going over the Ormus. And then August 8th, I just confirmed my next stream with Walter Bosley. And there's, oh my gosh, and I need to email Randall Carlson, as I think I actually got a stream coming up with Randall Carlson and the Medicine Hat Badland Guardians.
Could I please come on there with you when you have Randall Carlson?
Not the first time, but definitely down the road.
Okay. Fair enough. Fair enough.
Awesome, man. Awesome.
Much love, guys. Thank you for what you guys are doing. And we'll see you again, probably, if not sooner, but Friday night, free Energy Fridays. And be back. Hopefully try to make your Monday stream as well. And much love, my friends.
All right, guys.
Have a good one,
Have
buddy.
a great night. Thank you for the great stream, everyone.
Have a good night, Nathan. Thank you.
You too.
I really
Thank you.
appreciate it.
See you later, everybody.